I've got one. Oh, wow. It's on.
Hello, everyone. Welcome to the Systems and Infrastructure track here at SCaLE. Today we have Jess Males. He'll be speaking on this is OpenTofu internals. Thank you, guys.
Thank you very much. Pleasure to be here. I will call out some of my fonts do get a little bit small, so if you're in the very back of the room, unless you have binoculars, you might want to sit forward. So before we get started, just out of curiosity, how many people are SREs and use Terraform or OpenTofu on a regular basis? About half the room. How many are developers that are interested in contributing to the project? Okay. Anyone not used Terraform previously or not aware of where it's at? Anyone looking for a talk on tofu or tofu manufacturing? Excellent. That'll be covered in the part 2 to be given sometime next year. My name is Jess Males. I've been a sysadmin for 20 years. I do very much strongly consider myself a sysadmin. My preferred pronoun is ops or ops. As such, give me a terminal, preferably bash. Give me an editor, preferably Vim. Give me a command line game like Doom. All this squarely puts me in the camp of graybeard, which I don't mind, I accept, it happens. Graybeards are known for knowing their tools well, but also there's a little bit of attitude of get off my lawn or stuck in the past. But that being said, there's some very formidable graybeards out there. So again, it's a camp I'll happily embrace. But to be not stuck in the past, and just to make sure that I'm comfortable with modern tooling, not that I wasn't, but to really dig in, to really embrace that, I wanted to look at the OpenTofu code base. And so what I'm hoping that you get out of this talk is that if you want to break into this thing, it's very easy, it's very accessible, and if I can understand it, you can too. My whole goal for today is I want you guys to be able to walk away from here and not have any fears about being able to look at this code base or work with this code base, even if you've never contributed or looked at this kind of level code before. So, what is OpenTofu? Again, you guys identify that you're broadly familiar with what the tool does. It's infrastructure as code. On my left, your right, I probably got that backwards. Anyways, on one side of the screen, you'll see a sample bit of Terraform code. On the other, of course, you'll have to plan that out. The code tells you what it's going to implement. You apply it. It implements that. And by codifying all this in code, now all of a sudden we've got a time machine around what our infrastructure is. We can move forward and backwards. We can make changes. And we've got that history and also that identification of what needs to be built and how it needs to be built. OpenTofu, of course, is a fork of Terraform, open source, community-driven, and managed by the Linux Foundation. Why was it forked? Mid last year, HashiCorp, after 9-some years of open development under an MPL v2 license, decided to switch to a BSL license. There was little to no warning given to the community, and so there was quite a bit of reaction about this. I'm not going to dive into the politics of what they did. I think there's other benefits coming out of this. But just as a gauge of reaction, there was quite a bit of blow up. I watch Hacker News on a regular basis. I'm sure there's other gauges of the community. This is not statistical or highly validated at all. But again, quite a bit of community interest, quite a bit of blow up. And with that, the OpenTofu, they started as OpenTF, but OpenTofu as a project was formed and started going. And so some of the timeline is that August 10th, HashiCorp announced their change by August 15th, and then August 25th, OpenTF is announced, and then we've had releases since then. Public repos were started on September 5th, and then alpha release in October, as we see, beta release in November, and actually, considering the current state of the projector, no slides are as dark as this, so we'll quickly move on. But my view is that competition is healthy, and so OpenTofu, as an upstart, is very much interested in expanding features and expanding capabilities because they're trying to convince you to use this new tool. As much as there might be ideology involved, it's very hard to run your business on ideology, and it's very hard to convince management to make changes regarding ideology. But separately, as the incumbent, Terraform should want to innovate, because now all of a sudden they can't just rest on the laurels, they can't just sit still. As a quick note, most of the providers were not changed in their licenses, though they're still released under MPVL2, and this should be a strong unifying factor, making sure that there's not too much drift between the products. So with the idea that there's going to be competition, have we already seen that competition start to manifest? And tentatively, yes. I did a quick survey. This is, again, by no means scientific because, again, as we all know, semantic versioning has no definitive increments, judging by release numbers. Some projects have been in beta forever. Some decide when they want to move on. So, but counting roughly days between release, we have seen that 1.5.5 was when they announced that they would switch over, starting with 1.6, and 1.6 was released in October 4th of last year for HashiCorp, and then beginning of this year, 1.7 they released. They're already on track with 1.8. The beta just came out 2 weeks ago. And as we can see, all of a sudden that change, that increase is happening over time. And so understanding those changes, we use tools like version control to understand what goes on. With version control, we can quickly see the differences and changes over time. Unfortunately, as a side effect of copying that repo, they dropped all previous tags. So if you go to OpenTofu today, you'll find the 1.6 tags, and that's about it, which is a little bit unfortunate because if you want to compare against very past iterations, such as 0.12, 0.15, even 1.4, you'll not be able to reference it by tags. Again, it's Git, the commits are still there, you'll still be able to read all the notes, but that handy rough spec isn't immediately available, but we can restore it. And so clone your OpenTofu repo, add your remote ref to Terraform, and then fetch away. Now, you will want to take a couple extra steps to make sure that your tags are maintained. You've got a one-time line of disabling tag pruning during the fetch, which means that as it goes out to update its repos, it doesn't drop any existing tags that may not be present on that remote server. Separately, this second comment line here just clears up all tags because in the next step, we then go in and rename all the tags, prefacing them with either OpenTofu or Terraform. And so now, if you want to, you can do that diff that we had in the previous slide of Terraform v.14 against v.16, see those changes and get those on an easy reference. Now, doing it this way will grab all the changes, and so we've got that very important line at the bottom. Because of the relicense in the code, we don't want too much bleed there. In fact, we don't want any bleed. Do not copy your code from Terraform and try and commit it to OpenTofu. So if you want to be a little bit safer, you can specifically fetch the tags that are historic only. That being said, it is a little bit of a bear because you're then going in by individual branch names to filter out what not to collect. And then as time moves on, if we ever move to a 2.0 release, 3.0 release, that's going to keep on continuing unless somebody's much smarter with glob and wants to suggest a much nicer way of filtering that. So what's our model of what OpenTofu does as infrastructure as code? Again, we already saw some code. We saw that the plan goes out and identifies what needs to be made. The apply actually goes out and implement it. So we've got a series of resources that are dependent upon each other. Maybe we've got RDS instances, EC2 instances. Maybe we've got an IAM and policy that needs to be instanced. And so all of these things start building up. They start associating with each other. This all comes in together as a directed acyclic graph. Nobody ever calls it that. It's a DAG. But what that means is the acyclic part means that the pointers only go in one direction, so you'll not get loops, which is very important. Because if loops happen. You're going to get circles in your resolution, and then, of course, it's going to get stuck. It's going to run forever, and that's not something you really want to desire. So then, boom, we've got our code on one side. We've got our tofu, when it runs, starts matching up the resources with its in-structure memory of what that graph looks like. It starts matching up those resources that you've defined in your code. And then it goes out and looks at the infrastructure, matches that up, and then as part of the plan operation, does the processing, comes in and tells you, okay, this is what I'm going to do. If you were to apply, it goes and does it. And so with that mental model in place of it constructing this, it taking that graph, it walking that graph, it trying to decide what it needs to do in each individual case, let's go ahead and look at that from the outside in. And Tofu has some very nice logging features. It's just tflog equal trace in your environment, and then all of a sudden it starts spitting it out. There's several options for tracing if you want to get more or less verbose. If you want to get only half, the core part is for SCaLE. The provider part is for, of course, your provider, AWS, local, null provider, what have you, GCP. So if you want to collect one set of logs, that's fine, because as we'll see later, those get quite voluminous. And then if you want to, you can also set tflog path, and all of a sudden it starts appending all its logs. Rather than writing to standard error across the screen, it starts writing to those individual logs. So let's look at that real quick. With that, let's see. We're in demo 1. What have I got here? Terraform data. It's basically a null resource. All it does is it creates a revision. It does this local exec of touch a file, and this is, for demo purposes only, this code pretty much does nothing. It's a great example because what does it do? To initiate this, I did the command previously described, that tflogged. I've captured the trace log already. That's in these 4 files. The output is just the normal standard out that you would see. The standard error was captured in the trace files. And so real quick, from this null provider example, how many lines does that even produce? $780 lines. So quite a bit of output, quite a bit of detail about what it's doing and how it's doing. The reason why I particularly started doing this count is because when you start looking at other providers, AWS specifically, here, all I'm doing is just get caller identity. It's a basic call into the token service to say, who am I? What am I doing? And it's just a data call. It's not even trying to create resources. When this runs, how many lines does it produce? 3,500, so 5 times the amount in just making that simple call. If you actually want to create infrastructure, here's a Lambda. It goes on. I did not save, so let's do this count real quick. Yeah, excellent. That's even better. So again, if we're doing a much larger resource, how many lines is it going to produce? I expect this number 25,000. So lots of output as soon as you start doing those cloud providers. It's useful information, but again, it's quickly, very easy drowning in a sea of details. So swapping back, what's in one of these trace files? And with the cut, I'm just taking out the timestamps that would be the first column because that quickly becomes distracting. So let's just walk through it. It starts up, it tells us the version, it goes in, tells us some CLI output. It says, hey, attempting to open config file .terraform rc. Did you even know you had a generic system-wide config file? Here we actually use it in development. We use this file to override our providers. But again, in watching the output, we can follow along with what it's doing. So remember, it's going to try and build that graph. It's going to then look at that graph with the known state. It's going to then compare that graph to the actual state in production. And so how does it do that? Coming along, we see starts up, CLI arguments, goes down, tells us about what the terminals are. Great. Boom. Meta backend. So the backend starts to become a thing because it's now saying, well, we've got state somewhere, I need to load that up, and the backend is where that happens. It notes, hey, this is the override that I had in my Terraform RC, that's where it's getting that. The backend that it called out to is local, and it happens to note that the workspace is default. It's looking at the file system for that backend and noting that no previously stored snapshot exists, so it's going to create one and create a lock file associated with it. It creates a context object. Presumably that means something, or we'll find out that it does in a minute. It starts looking at plugins. It then builds and walks the graph. As we said, we'll see more details on that as it works. It then starts seeing config transformer, node validate resource, and then move on. And so all this exercise is to say that Terraform itself is going to tell you voluminous information about what it's doing, how it's doing. And even though it's a ton of information, it is pretty easy to read. And we'll put some of those details about backend and further context in just a minute. But in looking at all this stuff, we started noticing transformers. And so out of curiosity, what are those? What are the different types of transformers? Presumably they're doing something significant for us. And so I take the output here. I look for anything that's ending in transformer, single words. The -O is single words, looking for transformers. And then against those, the awk command saying, print out the first time you see it and skip all the rest. I'm not looking for a count of how many times I see these individual transformers. I just want to know the number of distinct transformers that it's coming across. And there's the list. So 47 different transform operations. We're not going to look at them all. We're not going to look at them all. But they're there, they're doing significant stuff for us, and they're all to be found in the code. So taking a look from the outside, the traces, what they're going to tell us, let's flip our view and take a look from the inside out. So if you've got the repo handy, you can start looking at it. I'm going to reference everything there, but now it's as if we're reading straight through the code to understand what's going on. There's a very nice architecture.md right there in the docs of the repo, and it has this very helpful graph of process execution. And as it kind of noted, as we're calling out, as reading through the trace log, the CLI starts up, loads up the backend, starts talking to the state manager. Then we've got this graph builder, graph walking, and at the end, transforms going on, which is all that vertex evaluation. So let's dig into this a little bit. The CLI. It's the internal command package right there in the repo. So OpenTofu /internal/command. It's mostly scaffolding for us, so it's a very easy to read file. It's going to parse the arguments for us so that we know if we've got changed as a flag. It's going to know if we've got output specified. It does all that for us. It can encrypt, which is something I'll get into in a little bit. It's a new feature in Tofu but not necessarily present in HashiCorp. It starts a backend for us, and then creates a context, and then from that context kicks off, and context is the main process in memory that holds the DAG and gets walked and moves on from there. So CLI is a basic structure for us. It does do keeps lock on the state so that too many things aren't changed at one time and we don't overwrite stuff. But importantly, if you don't know Go, it's got a very nice defer feature so that we don't permanently lock that. And so CLI takes care of making sure that that final lock doesn't happen. The configuration loader, which was on the side, basically takes care of tofu init processing, meaning goes out, grabs the providers, makes local copies available in your .terraform directory underneath your code repo where you happen to be running. It installs all those child modules into that environment, and then while running, as it reads those from disks, if you've got multiple instantiations of a module, those all get instantiated in memory as multiple copies, and they're fully interpolated so that namespaces don't mix up. And so if you've got two versions of an application, each of them get their own copy of that module so that variables aren't globally accessible across and then they don't get confused. With the slight caveat that at this point, we're just loading up the config out of the modules, so basically the source code out of the modules, and so it's going to interpolate as much as it can, but it's still going to leave quite a few big chunks of HCL body or HCL expression, just because it doesn't know yet what the count's going to be. It's not actually pulled up those variables of what those are going to be. It'll get all those later. The back end represents our workspace first. Even if you don't specify one, you're working on a default. If you specified something else, it takes care of managing that particular TF state file. The back end interface as a Go language construct has two versions, basic and enhanced. Most backends do not actually implement enhanced, so they actually run through local, and local takes care of loading that enhanced on top of it. The enhanced interface basically asks for apply remote plan features, and so when the execution happens, it happens through that interface of Golang, do that. The back end calls the state manager. Again, for us, it's file system local. Again, just picks up off the disk, pulls that in, it brings us, and then now all of a sudden it loads up that major context, which is represented in the context.go file. It points to the root of the graph and then kicks off graph walking. And so at this point, we can kind of imagine that the state's been picked up, all the code has been picked up, all those are present in memory, but variables haven't been interpolated. We've done the refresh so that we know what the current state is, but boom, it's still got some work to do. It's chunky. Also, part of the context, it creates stop hooks, which is, I think about it as a tin can of, hey, I'm going to talk on this end, you talk on the other. So if you ever hit Control-C during the middle of the operation, you've got that channel. Not exactly a Go channel, it's implemented through hooks, but it's got that way of communicating to those sub-processes that I bailed, save your state. You do have a little bit of grace period on that. Our config files are loaded. Each of them basically assigns a resource to a vertex. Be careful reading the code. You will see vertex and node used interchangeably. Vertex is preferred, but I didn't actually do a count of how often each term is used. But then context kicks off graph walker, which then starts navigating through that graph. Context is the entire execution environment for our code, but then as it comes across each module, it enters enter path and starts off that tofu eval context. And so now you've got, again, those per module environment variables separately namespaced. And so, again, a sub-environment, so it can't step on anyone else. It's pretty much doing the same thing. We've subdivided the problem. And then as we go across each vertex, it's going to try and do these concurrently where possible, but as it's build up in its transformers later, there's going to be dependencies, so it will respect those. The transformers as they happen, here's a sample of 4, but you can read your own, there's plenty in there. The config transformer populates config from code, turning them into resources. What does that mean? It means it's actually loaded up the module library, whatever HCL you've written in your local files, and then it matches those to resource vertexes. State transformer basically does the same thing, except it's the side pulling in from state. Then finally, reference transformers actually come along and say, that's the actual matching of determining, okay, these are the things associated and pairing them up. And so if you've got cross dependencies, it's doing that matching on that graph building. And then provider transformer comes along and says, oh, okay, well, you expect to be a type AWS EC2 instance. Great, we're going to map you back to the provider to make sure that code gets loaded before we even go on. How would you write your own provider? In doing that, it's actually pretty straightforward. There's a very nice series of developer examples available, but there's 2 versions. So I will caution, make sure you get the latest one, that being the Terraform Provider Scaffolding Framework, which helpfully they made the name very similar to Terraform Provider Scaffolding, so make sure you get the framework one there. The newer framework is more strongly typed. Previously, in the older style, you had to do a lot of casting and other management yourself. Everything fell back to a Golang basic interface, so getting the types right could be very difficult and sometimes trip you up. The structure provider basically has, for itself, a metadata method, a schema method, a configure method, data store methods, and these are basically registering its capabilities with Tofu itself. Separately, you will have a series of CRUD functions, create, read, update, delete, which are faced more toward your code. In fact, I'm going to skip ahead. Your provider being the center, it should be a very thin mapping, but on the one side you've got the configure side, which faces OpenTofu. You've got configure, metadata, data sources, resources. Those are all facing so that OpenTofu can come along and read you, and then those CRUD functions for read and delete talk more toward your API to come out and do those functions, and so that's what I'm referring to on this slide here. They're basically very thin registration methods, and writing them, you're going to write 5 lines of code just saying, hey, here's the functions I'm going to look up for resources, and you just start mapping those forward. As you do development, I will caution you, the OpenTofu framework, there's just some assumptions written about, hey, if you're writing a HashiCorp Terraform provider, you should be referencing Terraform, which was true up until August of last year. So in developing OpenTofu, you do want to overwrite those. But if you are considering writing your own provider, keep it as thin as possible. It should be a simple mapping. And then we see that here. Don't try and reinvent the wheel. Follow the leader. There's some very good examples out there. Grafana I like because it's smaller and more tractable. Of course, Terraform provider AWS being the 800-pound gorilla in the room is solid, it's large, it does a lot of great stuff, and so it's useful to look at, but you might get lost in it too. And by means of comparison, the repo size for Grafana is 3 megabytes, 180 Go files, maybe 30,000 lines of code. If you start looking into AWS, then you've got 200 megabytes to deal with, 7,800 files, 2 million lines of code. I find Grafana much easier to read from that standpoint. And then also, when building, the document helpfully provides this line, and I'm going to say, for the love of the flying spaghetti monster, don't do this. Rename your binary, because the thing you don't want to happen is going into troubleshooting and making changes to what the binary does, and you don't want those happening in production, and by having the same binary names, there's a chance that you mix those up. And then for the truly lazy, if you don't like typing tofu, 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 give yourself a convenient alias, OT. I like this because I often forget when I need to init and don't want to pay attention to it. So by default, it's going to check and see if I'm running init or I need to run init and create it if I do, and then move on. And then that else statement, just if I type in plan, everything else follows through. Or if I type in apply, everything else follows through. So if I need to do shorten state or anything like that, it just follows through. If you're not familiar with Golang and want to get started involved, I recommend this book highly. Particularly Chapter 3 is a great overview of Golang. How many have done significant projects in Golang? Okay. Chapter 3 for the rest of us. I can't remember the page count, but coming from Python and being very comfortable with Python, it's just a great adaptation, runs through the major features. It's a very great way to get up to speed with what Golang does, how it works, and what its larger thoughts are. If you are looking to get involved with the OpenTofu community, Slack is a great place to chit-chat with others. Also, there's issues boards, which is very nice to see what features people are missing or what's not working well. If you want to stay involved with the larger project, we actually publish weekly updates in the repo itself, which are very nice to read. The steering committee meets on an as-needed basis. The last time they met was in February, but their notes are published with part of that. The steering committee makes decisions about longer-term project efforts, hopefully getting a yes or no of we want to go in that direction, we don't, just to help people understand that, yes, this is where you want to spend some development time or not, just so that people don't spin their wheels. And then finally, the release notes, of course, are good. The project has been, of course, running since last August. What work is there to show for it? State encryption has been added. So if you want to further protect your secrets, your other production values, API keys, what have you, you can do that now. You can either choose to protect the whole file or just partial. You can also choose to protect plans. So if you want to run, or if you want to protect secrets while they're in your CI/CD environment, that can happen as well. That's pretty nice. If you are going to contribute, following up and raising issues, there's a couple templates on their GitHub page for doing that. You can file simple bugs, you can file feature requests. If you've got the idea of a longer feature and really know all the details of what you want to do, you can write it up as an RFC, and they've got some structure for that as well. If it's a minor bug fix, go ahead and write a PR, but if you think there needs to be a larger change, we appreciate the enthusiasm, but do open up a PR first and get some community interest, because if it's not going to align with larger goals of the project, they don't want you to spin your wheels and spend too much time developing something that isn't likely to get used or have to be refactored. And so save yourself some time, get the alignment first before you start hacking out too much code. That was my quick overview. Any questions at this point?
Questions, please into the mic, just so we can get it in the recording.
Well, thank you for allowing me to present. And if you do have questions, I'll be up here after the panel.
Are the slides going to be available on the...
Slides will be available. Who do I give those to, by the way? The slides. Phil? Where's Phil available? Can I email him? Do you have his email?
Check, check, check.
Check, 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 1, 2.
Test, test. It's working. Might be a little loud. Alan's going to fix that for me. There, let's put the microphone a little further away from my mouth. Does it still sound okay? Okay. We are at time.
Welcome to SCaLE's Systems and Infrastructure track.
Your mic's not on.
Test. Let's try again. Yeah, that's a good picture. Welcome to SCaLE's Systems and Infrastructure track. Today we have Heather Osborne, who will tell us about why organic isn't always good for you.
Thank you, Alan. Welcome to my talk. I'll let you know right away. We are not going to be talking about extolling the virtues of GMOs over organic. This is not that kind of talk. I am not that kind of person. Okay, you're welcome to go, that's fine. So the title is a net result of me being a snarky nerd who sometimes thinks she's clever and or funny. So what we're going to talk about here, well, first we're going to introduce me. So I am Heather Osborne. I am a 25-plus year systems engineer, DevOps, manager, architect kind of person. I spent about 24 years at Ticketmaster, where most of my career was. I worked on legacy and on-prem systems. And then a couple of years ago here, I did a talk to that effect, modernization as a forcing function, talking about how to encourage people to move on from these legacy paradigms and move toward the more modern solutions. This talk is not on purpose an extension of that talk, but it is just by the nature of my career development over the years. More recently, I've been at a couple of startups, and I'm making a little bit of background noise. A couple of startups on public cloud. Everything I've done since 2020 has been entirely public cloud. And I've served as both a senior director of DevOps as well as a system architect. So a little bit more about me. And I gave you some of these systems ideas here. A little bit more about me. I'm a bona fide crazy cat lady. I've got 4 of the beasties. I had to air gap my clothing and my laptop bag so that I could come here and look moderately presentable, not covered in cat hair. They are particularly adept at walking across my desk when I'm in the middle of a production console work that I'm doing. And I'm also a distance runner, so I get a lot of time to think about these things while I'm out running. And I will say I'm an immersive camping enthusiast. And if you want to know what that means, you can ask me later, but I basically consider it I go out and be a jackass in the desert at really weird events. So, what's the story I'm telling here? Because organic isn't good for you in every case. The analogy fits, particularly in the case of infrastructure. Just because it's not artificial, just because it's not, just because it's fake doesn't mean it's not good for you. I want to remind you that because it's organic, it doesn't necessarily mean it's good for you. And as I said, this particularly applies to infrastructure. You have the rapid organic growth, you have all of these things that you can no longer decipher. You can't figure out where the vine goes on the fence. None of these things. So, how many of you work in a well-architected environment? Raise a hand or two. Oh, I see the architect over here raising his hand. Were your systems painstakingly designed and laid out with a thought towards all the abilities? The security, the stability, the maintainability, the sustainability, the general promoting the go to bed on time ability. Nope, okay. Alan over here is going, well, yeah, I wasn't expecting to see a lot of hands here. So this is where we're going with this. So what is the story we're trying to tell? And I can't read my screen. This is great. Okay, I got it. Never mind. So the first segment we're going to go to is how you end up creating an organic mess. Next one is we're going to tell the story of the background spaghetti. And then we're going to figure out, do you really know what's wrong with your systems? Probably not. And then you realize, whoa, this is actually a bigger problem than we were expecting. And you might as well just yeet the whole thing. You're done with this. There's no business in keeping this around. It's more effort than it's worth. And then finally, we'll talk about what we did, solved it with tools for fun and profit. So I said I spent my 24 years or so at Ticketmaster dealing with legacy systems on mostly on-prem infrastructure. I'm going to give you the story of my more recent journeys at startups. My unfortunately recently ex-company, it's not a good time for tech startups, so be it. But the name of the company is irrelevant. The story still needs to be told because I feel this is something that I've hit every time I've worked anywhere. Every systems I've encountered have been this organic mess of a beast that grows over time. I will say that one benefit of this being at a startup is that it's not as deeply entrenched into the infrastructure, and it's less far to back out of it to get yourself on a good path. So the model of a startup, you have, my microphone is bugging me, I can hear, pull it out a little bit more. I can hear myself moving around. So the model of a startup, you hire some people with some brilliant ideas, super smart people. They have this idea that's going to make you $1 million. Let's go run with this. $1 million a little undercutting it, but it is what it is. So these people are not necessarily infrastructure people. They don't know what they're setting up. They have no idea what a VPC is. They have no idea what an internet gateway is. They don't know what database to use. But in this day and age of cloud services, you see these ads come up. Set up an application in a day. They see this on the AWS site and they go, ooh, I can do that. And you get a whole team of people working together. They're really smart developers, but they still have no idea how you should back things with a database, how you should set up security groups, none of these things. But we use Elastic Beanstalk as an example. That's this quickly launched web applications is one about Elastic Beanstalk. Bam, the site's up. You've got this great site. It was a great idea. You're making all sorts of money on it. You've got people asking for features because this is something that you want to expand and run with. Well, what happens here? Well, it's booming. Let's hire some more engineers. Let's get these features built in. This expands into organic growth. You start adding things to the things that you already created that you didn't necessarily know how they worked in the first place. You just bolted some things onto the side of it. And then you go, hey, we should probably hire a DevOps engineer. And I will say, DevOps engineer is a misnomer. It's not an occupation. It's a philosophy. But for the sake of argument and for the sake of ease, I'm using the term DevOps engineer and or SRE interchangeably. So you get your first DevOps engineer. They come in and they go, wait, what? What is this business that I'm looking at? What is this nonsense? What is this organic beast that you've just now unleashed me on? And we have to be compliant. How do we get our security laid out in such a way that makes sense? Because I don't even know how this application works. How do you do your releases? What is it that you do? How do you promote it through your environments? Where's the code in the release process in the software development cycle? You got your software in my infrastructure as code. I got my infrastructure code in your software. Things are tightly coupled. You can't unravel it without going very much in depth. So how do we start untangling this, and how do we start thinking about it? So, as I mentioned, this is the tale of my DevOps journey at startups. We've got all very knowledgeable and talented people, industry best practices. This is me referring to my DevOps team in particular. They understand the industry best practices. They know how to work with our stack. We'll say AWS, Kubernetes, GitHub, using Terraform for infrastructure as code, and backed by a Postgres database. For the most part, it's primarily Ruby on Rails, and we use Istio as a service mesh. So this sounds absolutely straightforward. You go, okay, that's, yeah, standard web application built on public cloud. Well, if you go back to the concept I was saying about a startup and the folks who built it not having necessarily an idea what they were doing when they built it, you end up with things being put together by trial and error. You got the organic growth, and you've bolted some things on the side of it. You've copy-pasted code because it worked before doing this thing, so let's just change a couple of values in here and make it do something entirely different that was not related to what it was designed for in the first place. You end up with an epic spider web, a big pot of spaghetti, a ball of yarn. So before the current team got involved, there was a great concept of how to enable developers to move quickly. We used ephemeral environments that we referred to as ODEs, or on-demand environments. This worked great for a monolith. Things don't always stay a monolith. You, again, bolt things onto the side. You got that organic growth. The spaghetti is leaking out of the pot. And this is driving me nuts. A little below my chin? Okay, let's see. No, I appreciate it. And it's like, I don't need to hear myself breathing. Whoa, maybe not. Okay. So this on-demand environment is a great idea for the monolith, as I mentioned. It spins up a temporary Kubernetes pod and basically puts your code there, runs all the tests, spins it down, and then it's ready to roll to production. So that's great, but what happens when you branch that application? What happens when you throw some microservices in the mix? You add an authorization service. You extract the front end from the monolith. Now you have these short-lived environments that they spin up, they do a thing, they test the monolith, but they are not QAing your code at all. All you have is just this very small piece of the picture that is being tested. Also fine, you need a more robust test environment. But you're not allowed to touch dev because, as I mentioned, things grew organically. The dev environment was originally supposed to be a proof of concept cluster and not actually an environment. You have in prod, you have Beanstalk. In dev, you have Kubernetes running. That means prod and dev are nothing alike. The code's the same, but the mechanisms behind it are entirely different. Well, people need to test their stuff. So what do? You build a release environment. The release environment being a little more like prod, kind of like dev. It's got the microservices, it's got the auth service. It's part of the dev cluster. It does things that moderately resemble prod, but are not actually what you want to be doing. Another problem, only one person can use this magical test? Okay, thank you. It was very loud and disconcerting. Only one person can use this magical test environment at a time, and you have no visibility into what it is that this test environment is running, what version of code is running, whether it's currently being used for UAT, whether it's currently being used for microservice testing, et cetera. So we can't mess with dev because that would impair developer velocity. We don't have the resources or the time to build out this on-demand environment to be a little more robust and include the microservices and the other services. So what do? You know what? You might as well test in prod. That's the closest thing to prod as you're gonna get. So the team sat down one day to make a simple change. We had an alert saying we weren't getting all of our audit logs. That's a critical alert because we were required to have audit logs. So one of my engineers sat down, started debugging it. I went, okay, it's a problem with FluentD. We're just going to upgrade that. Take a second. Nope. We don't know why that's where it is. Okay, well, we don't know why if I put this block in here, it doesn't do anything. We don't know this. So we pull in our lead dev. We pull in another dev. We pull in another dev. Pretty soon, there are 5 of us, including myself, sitting there debugging a very inconsequential problem because, you can adjust it again. Thank you. Which means when I exhale, it's going to make some really interesting sounds. Can you still, okay, I'm still on the mic. We'll see how this goes. So this simple change that we're making, theoretically just upgrading FluentD, figuring out why it's throwing an error, we ended up with 5 well-paid engineers sitting on a call for the better half of the afternoon. This is a huge waste of resources, and this was by no means an isolated incident. You have all of these problems that because your code makes no sense, because your infrastructure's code makes no sense, because it wasn't developed by someone who gave it half a thought before they put it in place, you end up playing this game of unravel a little bit of the sweater. Oops, that's not it. Let's tie it back up. Let's unravel the other sleeve. Let's go figure things out. You spend days and days on end debugging simple issues. And don't even get me started. I am the one who was responsible for cost optimization. Like, oh, look, there's a Microsoft SQL database sitting out there. What is that? Nothing's tagged. Another addition to that pile of problems where we can't figure out where the source of the problem is. So nothing's tagged. We have a Microsoft SQL database out there. Nothing in our shop runs Microsoft. Why is this thing here? It's costing us $3,000 a month. Well, let's destroy it. Well, was it built by code? Was it built by ClickOps? How do you get rid of it? If I destroy it ClickOps and it's in code, is it going to come back? What do you do? All of these problems just resulted in us going, wait, what is this nonsense? It is just worse and worse and worse. So we need to figure out what's wrong. What in the name of organic nonsense is this infrastructure that we're working with? We can't provide the software engineers with what they need. That's a testable environment. We can't unleash them on their own to operate in the true sense of the term DevOps because the Terraform was so convoluted that DevOps would spend half a day figuring out what was going on. They couldn't reasonably dissect it. I fondly referred to this as Terraform. And we also couldn't be happy DevOps and security engineers because there's zero consistency, there's zero documentation, there's no failover, there's no disaster recovery, and there's no best practices. When we read a white paper and we go, ooh, that's great, let's incorporate that. There's no path to that when you have this overly complex environment. So what do? We need to determine where it hurts. One thing I've learned over the years, developers will say, it sucks. You know what? It sucks is not an answer for what's wrong. It is a blanket term that's used for every technology issue. Well, what's wrong with it? It just doesn't work for me. Also, not helpful. Doesn't tell you a thing, doesn't tell you where the problem might lie, doesn't tell you what we can do incrementally to help get you out of this blockage that you're in. So to start trying to unravel this issue and move to a model where people can speak about things intelligently as a factor of tech maturity, more eloquently than it sucks, you need to actually talk to the people. You can't throw out a survey monkey and say, okay, what's wrong with X, Y, and Z? They'll just answer what's wrong with X, Y, and Z, and it won't be data that you can actually use and make into something or make into pain points. So what we had to do, I conducted an interview with every team lead and a member of their team to figure out what was going on. My intent when I kicked this off was to find out what are the low-hanging fruit, organically, of course. What can we do to unblock the developers? So I'm going to show you a big, nasty diagram here. And I don't know whether you can read any of these. But this was the net outcome of my interviews. And apologies for the typos. Because I no longer work for the company, I transcribed this from a screenshot. So it's my horrible typing. But I broke things up into groups about whether things were taking too long, whether it was a consistency problem, whether it was a documentation or a policy issue, whether it was a test environment issue, simple complexity issue, well, that's irony or oxymoron there, whether it was a release process or a testing process issue, and broke down things by the teams, broke down things by the security team, what things impacted everybody, what things specifically impacted the data team, and found some patterns around these things, found what it was that was really the root of people's pain points. And you'll see here there are a lot of things. Can you actually read this from somewhere? Okay, that's great. You are one up on me. So I'm going to move over here to the side so I can see this one. So we got some of the release process, testing process ones. No decommissioning or offboarding consideration. This goes back to my original talk about getting things to move to end of life. We have out-of-date documentation. If you look at the data column, we have an entirely separate data ecosystem than we do app ecosystem, which means that they are doing things very differently from how the application teams are doing things. We have things like the on-demand environments are called out there, that we don't have the microservices attached to them. We have some things like the product and design teams are trying to do UAT against the release environment, and there's only one of those release environments, so that's not sustainable. The complexity, we have we couldn't set up a new firewall. We couldn't test out new software, such as adding Confluent to the mix because of the way the network was set up. So it was okay, we have to go rip off the Band-Aid. We can't test these things in advance because we don't have a infrastructure or security specific environment to test in. And let's see what other ones. No standard, no load testing. All of these things are very common. As I said, none of this is very specific to the company I was working for. This has really been a plague of all of the companies that I've worked for. But this was particularly interesting to me because I had the luxury of being able to actually collect some data and get some patterns around what it was that was causing the legitimate issues. So if I was following, yes?
What do the colors mean?
The colors, the legend is down the side.
Thank you.
And like I said, never mind my misspelling. I know consistency is spelled wrong, among many other things. I started to try to load a new copy of this with the spelling corrections, and I couldn't do it from just my laptop because my screen was not big enough to take a screenshot. I just went, never mind, you get to deal with my typos. Don't have budget? No, budget. Budget comes in the next part of the discussion there. So because this was so huge, if we were doing an agile process, we would have done an inception, we would have figured out what we were doing, we would have figured out the plan, but there was way too much going on here. So we had to take a two-pronged approach. And I'll say we also had the luxury of having a developer productivity team. They were more developer-facing. They were a lot more in tune with the very small bits that they could correct to help the developers in their day-to-day life. So they were identifying the really, really low-hanging fruit. Like there's one up here that's move this to a script, and then there's one that's we don't know in Slack when something's been released. So those were the sort of things that the developer productivity team was able to take care of. they decided to be on the side working on a number of these things, and this was great because it gave the engineers the idea that we were working on things really hard for them. We were trying to unblock them. We were trying to make it suck less for them, you name it. So a couple of the things that that team did, and these are their story. These are not the area the DevOps team was going, but just so you get a little background. We added some observability to the release environment so we knew what versions were running there. We added GitHub merge queue, so you no longer had to sit there and wait until a Slack channel updated with this person is done. Now Bob can take over because George is done. We set up a golden DB because we always had stale data in these on-demand environments, and releases data, as you can see here, releases data was nothing like prods data, was nothing like on-demands data. So you want to have a set of data that is consistent across the board. We improved the pipelines so that more of the testing could be done locally instead of chewing up our GitHub action minutes. There's some cost for you. Incorporated API contract testing, which hadn't existed previously, or it had and nobody had bothered. The DevProd team, the developer productivity team, was a fantastic partner in this whole endeavor. But as I mentioned, these ones I just listed here were their story, not the DevOps side of the story. They were happening in parallel to knock out some of these more immediate pain points. So, what was the DevOps side of things going to do? Well, we had a huge infrastructure problem. Obviously, I see Mark over there rolling his eyes. We've got a couple of choices. Well, choice one, greenfield. Yes, that's a bad word in a lot of cases. You know why? You have this really wonderful system that you've worked on really hard and it's perfect and everything's great, and then you release it to the wild and 60% of the people move over, and the other 40% of the people are like, I'm not going to bother. And then you end up supporting both the brand new shiny system and the old system that you wanted to get rid of in the first place. So we were understandably hesitant to go down this route. Choice two. I mentioned prod is different than dev. Dev is on Kubernetes. Prod is on Elastic Beanstalk. Technically, dev is the newer version, but prod is the more consistent version. What do? Well, in theory, you clean up prod, as in let's get it upgraded to Kubernetes. Let's clean up some of the logic issues around prod. I don't know whether you saw on the past slide, it was dev had overlapping subnets. That was why we couldn't just upgrade dev and move forward with that. The concept being you clean up prod, you make a copy of it to dev, you use that as the new dev, you use the new dev for doing your more complicated release that you need to do, and then you go back and forth until you iterate through what it is that you need to do. So the estimated time on that was at least 12 months because you needed to be slow and cautious in getting these things cleaned up. You're still messing with production, you're still doing things untested, you're still doing things that are the whole reason you wanted to have a solid dev environment in the first place. And I didn't mention at the beginning of this was an urgent issue. This was something we needed to resolve now. We didn't have the luxury of 12 months to work on it. And then choice three, this is the one that makes me cry, improve in place. This is a continuation of the effort where we just kept spending all afternoon working on a very simple item that should have taken us 15 minutes. Another problem with this is we didn't necessarily have the time, nor did we have the personnel to lock in a room for half days figuring out each step. It doesn't necessarily have a quantifiable time to market. We couldn't even throw that 12 months to get it to market. And it also doesn't have a definition of done. We don't know when we've finished what it is that we were trying to do. So we took this and we presented it to the people with the money, back to that budget thing, and we laid out a very careful matrix of what the risk assessments were, what the time to market was, what the associated costs were. For example, the cleanup prod copy to dev, that was going to result in a duplicate environment for a significant period of time. Greenfield was going to have an extra environment, but you could move a lot faster in that extra environment. You name it, we did all of that analysis, and I don't have that sheet to share with you, but let's just say we went through all of these things. We ranked things by scores. We tried to figure out what it would do, what we could do most quickly, what incremental improvements we could offer, what low-hanging fruits we could give to the developers to show that, yes, this is something that's helping them. So our path to buy-in, we've chosen the greenfield environment at this time because both of the other two options we had out there were really not a viable option. Like, it pained me to say that the greenfield was the best solution because I've been through it before, but there really wasn't a better option. So we presented that matrix, and everybody went, yeah, you know what? I think you're right. I think we're going with the greenfield version. Nobody wanted to continue with the convoluted, untestable, maybe secure infrastructure that we had. And we wanted to have a path to getting people to upgrade by making it so appealing, making it so fun, making the toolbox so easy to work with that they wanted to move there. It wasn't a, let's go play in your Terraform for 6 hours to get you unblocked. This was a, oh, here's the thing, and this is the way things should work together. So we got the go-ahead. I segmented my team a little bit. As a management person, I don't like getting one section of the team something new and shiny to play with and making the other guys play with the old stuff. It's just bad practice. It lends itself to a lot of unhappiness. But what we were trying to do, we were trying to cut down the existing support of our current infrastructure so that we didn't have to. It was a keep doing, start doing, stop doing type of thing where we could say, this is not helping us. This is not something we want to sustain into the next year, so let's just stop doing this thing. And we could then put more resources towards building the new instead of just focusing on fixing the old. Obviously, break fix and things like that were going to be still an issue, but the bulk of the effort was put towards building the new environment. So what do we want out of a new environment? Well, we never want to do anything that's not in code. We had just a mix of done in code, not done in code, and we had no rhyme or reason to why things were the way they were. We wanted to always include code validation, or include everything validation. We want to make sure that things are ready to go. We know from the ground up that things are ready to go. We want to keep documentation close to code. How many of you know what a graveyard confluence is and where all of your documentation goes to die? And unless you have a full-time dedicated tech writer, which I don't think most of us have the luxury of, you really can't find anything useful. You do a bunch of searching and hope that you find a keyword that might match. You put your documentation in the same repos as your software. That's how you find your documentation. We simplify the product engineering job. They don't need to know the ins and outs of Terraform. They don't need to know the ins and outs of Helm charts. They just need to know what they're asking for. They need to know what it is that they're trying to build. They need to know why they're trying to build this. And mind you, we're providing a paved path. They don't have to go down the paved path. They can do off the path and support it themselves. But that's a choice. That's not the way that we're making them go. They can diverge if they support it on their own, if they have the know-how to diverge from that paved path. If they don't, they can go down the normal path and everything works the way they're supposed to. Testability, that was most of that grid that I showed you. Was we had no way to test things in prod environments, etc. Consistent environments, that's another one. Dev and prod, nothing alike. Security, what environment? We don't have one of those. We wanted a low-touch release process with visibility. We wanted to know what version of code we were on and where it was at any given point in time. We wanted to have some pretty sturdy guardrails so that we didn't have Terraform spaghetti again. We wanted to make things more straightforward, be able to see the bigger picture without having to spend the hours dissecting the solution. No spaghetti. Spaghetti is bad, especially organic spaghetti, especially those gluten intolerant among us. So, it's so clean. What are we doing here? We're doing some declarative GitOps here. We want to promote the desired state to the intended environment. So we creating a platform cluster. Oh my goodness, DevOps has a playground. DevOps has a place where they can do things. We have an environment that we can now test changes without impacting production. Previously, we were entirely test on prod. The folks working on our product delivery, all our Jira and stuff like that was, why are you skipping over the section about testing? Like, once we merge code, it's in there. Sorry. As well, security was going to be thrilled to have a test bed as well. I want to test this new firewall. I want to test this WAF. I want to do these things. They wanted an environment to do this. So we're going to create an app alpha, a platform alpha. We're going to create a platform beta. We're going to create a platform stable. Code will never be deployed directly to platform stable because things should be promoted through the lower environments for all of the validations that I mentioned before that we were aspiring for. Obviously, there will be a break glass because reality, but that's not the way things are supposed to go. And then when we start going to app, everything will have had to pass through the alpha, the beta, and the stage again, or in the stable again. It's the equivalent of dev, staging, and prod. So, I'm showing you some diagram here. What is the problem we ran into? We want to use the same tools to deploy the base infrastructure as will be used to deploy the applications. Who would have thought that we would actually want to use some consistency in our tooling across the environments? So this actually caused us a little bit of slowdown. We realized that our old templating process, the cookie cutter, wasn't going to meet our needs because it was as spaghetti as everything else was. It didn't follow the normal paradigms of something like a cookie cutter application. So it was unnecessarily complex. And as well, my team sat there for days going, wait, what is this thing doing? Why is it doing that thing? So the decision was made to do this before we moved forward. So we moved all of this cookie cutter concept to a GitHub application that uses GitHub topics to subscribe to template repos and get updates. So this saved us from our current complication, which was we make a change to the cookie cutter, we push out all of these PRs that everybody needs to merge, everybody looks in GitHub and goes, oh, there's a PR there that needs to be merged. It's not mine, I'm gonna leave it there. And then we end up 3 months later where nobody has updated their templates. So this was a fairly quick win. As I mentioned, we wanted to give the developers a quick win so they could see the benefits of what it was that we in DevOps were trying to do. It took a lot of the heavy lifting off of the engineers' hands. They no longer had to go merge all of those PRs that meant absolutely nothing to them. They now had a version control. They could see what it was that was being changed with every iteration that went out, you name it. So once we got this aspect of deployment straightened out, we were able to run with starting to set up our EKS clusters. So I'll say we worked with a mix of the Amazon EKS blueprint as well as some of the grunt-work reference architecture for coming up with the general best practices for setting up EKS clusters. And I'll call out here, this diagram was drawn in SCaLE. If you don't know SCaLE, it is fantastic for making simple diagrams. It's open source. We found it. Some salesperson was doing a demo for us, and they were using it while we were on there, and it was super easy, and we went, ooh, that's neat. I need that. I see everybody looking it up on their phone. I don't work for SCaLE. Okay, so I mentioned that one of the things we need to do is validate everything. We want to validate in local, so we're going to use things like pre-commit hooks. We want to detect the problems before they move to version control. We want to keep it out of the more expensive side of things. Don't put it in GitHub if it doesn't need to be in GitHub yet. We want to validate in CI. So we've got conf test and things like that, testing against the structured configuration data, so we know exactly where we're going with that. We want deployment validation. So we've got gatekeeper OPA there. We've got an admission controller for Kubernetes to enforce the policies in real time during the resource creation. We explored a little bit with Kyverno, but we opted to go the gatekeeper route. And then the validation in cluster runtime, we use AWS Guard Duty for that, just to figure out the threat detection and things like that in advance of having. This is independent of our application necessarily, but we want to get everything completely validated before we even spin up the infrastructure and then continue on into the application. So, tools. What tools did we use for building this all out? So we've got Cargo/Argo, so the continuous delivery and a lifestyle orchestration. So as I mentioned, we never deploy too stable. We promote things through the environments and use the concept, the terminology called out by Cargo. They refer to things as freight that you ship through the process. We do all the validation at the lower environments, including the container images, the Kubernetes manifest, the Helm charts, the repositories, et cetera. We use Harbor to store the artifacts and have them pre-scanned. We use GitHub Actions and GitHub Applications. Istio Service Mesh, we did have Istio before, but in the idea of folks that don't know what they're doing setting something up, and Istio being a fairly complicated thing if you don't completely rein it in, we ended up with this a very big mess of Istio that wasn't doing at all what it intended to do. And the thought of upgrading that thing struck terror in our hearts. But setting up Istio from the ground up so that you knew exactly what it was doing and it was specifically set up for your environment was not a bad call. And then Terraform, hopefully this time with less terror. Had I still been employed, I would have been showing you a demo right about this point. But I thought that the story of how we got to thinking about building up environments that are using things in ways that they should be used was still a valid story to tell. So, with that, any questions? That is Bishop. Yes. Oh. Oh, right.
Not for nothing. Back at the beginning, did it ever just occur to you to just shut down your Microsoft SQL database and see who screamed?
So Mark, you probably dealt with me doing that at Ticketmaster a couple of times. We did, that's ultimately what we did, but it didn't answer the question of whether it was in code or not.
So how did the team respond to change happening, and what did you have to do to be able to get people to buy in? Or were people pretty bought into wanting to go to the golden path in a new shiny way?
I couldn't quite hear you.
I can just speak loudly.
Okay.
Oh, yeah. So what did you have to do to get the team to buy in? How was it received? Did you have to do kind of an internal evangelizing effort, or did everybody kind of realize that you had to change and that this was a good thing to happen?
So this was what I was saying about needing to show the incremental improvement. We didn't want to go develop a new infrastructure in a vacuum. We needed to show little bits and pieces that would be appealing to people as we went along. We had to keep the regular demos going of this is a thing, this is the way it works now, this is what we're going to move towards. The developer productivity team I mentioned was very in tune with it. They were very gung-ho about it because, like I said, they were doing the let's pick the little bits off the corner of the glass and make it a little more transparent. They were evangelizing it more than us. We were working on getting it set up in such a way that we would be able to move to it sooner than later. But when I mentioned the replacement for cookie cutter and being able to get those things, people went, oh, that's great. I don't have to merge all these crappy PRs that I don't know what they are and why they're there and why are they even here. I'm not going to touch them and get the most recent version of things more easily than they had been in the past.
Yeah, similar question. Do you, I have written several product plans as a developer, right? Because I want to be able to convince my bosses or, you know, just lay out all the options, right? But you talked about, you know, cost and risks. And do you have any recommendations for general best practices? Because most of what I do is I lay out a feature matrix, but I don't really consider maybe the business impact and that sort of thing. And I do think that's the next level for me.
Yeah, that was a very useful exercise for us to be able to sit there and we basically did a ranking of 1 to 5 of how risky is this? How much is this going to cost? What is the duration of having something, you know, an environment that's not getting any traffic, having that stood up for X amount of time versus having a exact copy of the huge environment that we have that probably has a bunch of garbage like that Microsoft database that doesn't even need to be there, having a full clone of that and things like that. So it was a super useful exercise to be able to think about it from the business perspective. That was where I got pulled into it, was trying to convince the people with the money why it was that we were doing these things. The tech people are usually relatively easy to sell. If you say, I'm giving you something cool to work with, they're going to go like, sure. It's the business people who are signing the checks that are going to be the ones who are a little more hesitant. And if you can convince them by way of data, then usually you have an easier time of it.
How long did this take you?
This, the part we got up to, so from it's time to start thinking about what's wrong with things, so all of the assessment and the interviews and all of that, I'll say that started a little under a year ago. And then all of the assessment, we had kind of buy-off by summer. And by summer, we set up a POC of, yes, you want everything to be done in code, but sometimes you need to take a break and do things, some click ops for a little while just to get your ideas down before you start committing it to code. So we did a POC that was due in September. From there, we were going to do an MVP, minimum viable platform. And that was going to be where we could start rolling through the process of setting up the infrastructure using what it was that we were going to use to ultimately deploy code. So that was, I'll say that was due like a month ago. So it's a better part of a year still, but it was, we realized, a significantly heavier project than we thought it was going to be when we kicked it off. It was like, oh, we'll just fix it for the devs. It's no problem. We'll just do that. And it got that original project when I first started got tossed between team after team after team. Like, oh, I can solve this. Oh, no, I can't. Oh, I can solve this. No, I can't. You just needed to rip off the Band-Aid and go build it fresh.
And I know you said you're no longer with the company, so I don't know if you can answer this, but I'm curious about adoption. Was it successful?
I'm still in touch with the team, obviously. The team is still working on it. The infrastructure is stood up now. They are working on getting the initial applications ported over. And one of the things about getting the cookie cutter type situation set up was that you could use the same one on the legacy code as you could use on the new code. And that was something that was going to make this step a lot easier to take to moving to the new environment. But what we wanted to do was move the monolith over. That wasn't necessarily going to be the easy one at all, because that was going to need to get migrated to Kubernetes and so on. But it was a let's pick off some of these microservices and get them moved over, at least get them using the new cookie cutter, or templater is the better word for it, but let's get them moved over to using that. And then when it comes time, we can just stand them up on the new infrastructure.
Were there paying or contractual clients in production that kind of had issues that forced this change in architecture, or internally did they figure it was such a mess they needed, did they realize it to themselves that there was a problem that needed to be resolved in the way they originally set things up and went from beta to production?
So this was not customer facing. There was not an impact to the end users that were seeing it, but it was the folks on the inside that said, hey, we need to upgrade to this version of Postgres because it's going to go end of life on AWS if we don't do this now. Well, how are we going to do that without causing customer impact? And that's where we started to have to think about things like, how do we do these upgrades? How do we test these things without just... We had to do a database upgrade where the easiest route was, let's just cut over to the new one, see if it works. Okay, cut back. And that was not an ideal state to be in. And we, the nature of the business, we didn't want to impact customers at all. It's, it's healthcare industry, and we really don't want to leave somebody hanging on that front. And it really was grown from the developers going, this really sucks. And we had to figure out why it sucked for them. Like, yes, DevOps knew exactly why it sucked, but to try to serve our customers, the developers were our customers, what was it that we needed to do to make it better for them? And ultimately, time to market for products and so on was serving the customers outside of the company, as well as the customers, our DevOps customers of the product engineers.
Was originally something that was like a startup that had built into something with a whole bunch of spaghetti, and I imagine that you got a whole bunch of metrics for it, and then when you grew into this, you had an idea of what it was you needed and ended up deciding what you were going to create afterward from that. But if you were to instead just create an entirely new organization, what different things would you be doing as a result of what you had learned from this?
So I think the question was, I had the benefit of a little more flexibility because I was in a startup organization, but if I ended up in a different, bigger organization with a little less flexibility, how I would?
Not quite. If you were to do this all over again kind of thing, right? Like, I don't know if you were here when the business had originally started, but I imagine because you were in this and you had time to figure out what it was you needed, right? Like you would have gotten metrics, for example, for what it is you needed in your greenfield. But if you didn't have that, for example, and you were just setting up, here's a new business, would you have some new lessons you would have learned from it as a result?
Okay, I see what your question is if I had the information I have now and I was setting something up from scratch, would I be a little more successful at it?
Yes.
And I would say yes, hell yes. The more you know, the better you are. And I am thankful that I had this experience because I now know what sort of things can go absolutely wrong. And obviously that's going to change because what you knew yesterday is different tomorrow. And being able to at least form the concepts around dissecting what it is that needs to happen is something that will carry on into the next round. You got to keep up with the current technology. That's why coming to something like this is great, because you get to hear what the next generation of things is and be able to work from there. If you know what it is that is the problem in your environment, you can start something new using the new and shiny that's outdated a week later, but
would you have any particular things that you would, that come to mind for, if you're making something new, these are now the things I have in mind?
I'm sorry, I didn't catch that.
So if you were to do that, do you have, these are the new things that I would have in mind to do, right? Or would you just say, now that I have the experience, we can do it better? Is this an experience thing, or are there other takeaway lessons you could make from it?
At least at this, you were asking, with the knowledge of the new stuff coming out versus the experience I had, which way I would go kind of thing. I would say at this point, I like what we came up with, and I would run with that for a little while, because I'm still a fan of Argo. I've actually used it in my previous job as well. It gives some visibility and a little more flexibility, and you can see what's happening in your environment without having to manually break it apart, and I do enjoy that. And I was a bigger fan of GitLab. I know GitHub is a sponsor here, but I'm now a fan of GitHub as well. So I appreciate those areas that we can roll through. I do like the idea that was actually a good idea that we were trying to keep along, was the ephemeral environments, being able to spin up an environment and test offsides and not have to manually do that every time. There's a lot of concepts, over years of experience, you pick up things that you go, oh, that'd be great, I'm gonna reuse that idea. And then next time you go, ooh, no, never touching that thing again. So it's really just experience, trial and error, knowing what's going on for a particular company. And they're all gonna be different. And I'm not sure the microphone is working. How did I convince the business people to go along with it?
Yes.
Okay. I caught that you could convince the developers to go along with it, but how do you convince the business people to go along with it? I'll say that unhappy developers are very loud developers. So you'll end up with them telling the business people that it's the infrastructure causing them problems, and that's why their features are not making it to market, or that's why DevOps is a roadblock, and things like that. So if we could get the data out there, get the assessment of the environments, get the assessment of what it was going to take out there, then it was a lot easier to convince the business folks, because we were impacting their developers, impacting their new features to market, impacting these things. And effectively, you're just taking away excuses. So once they got the concept that, yes, this was a problem and this was impacting the business, then it was easy to go. As long as you can say what the money looks like and who it's going to help, then I think that's a fairly easy, I won't say that's always the case. I've been in companies where you got to convince somebody that I need one extra server, please, just that extra server, because we have that much more traffic. In a reasonable company, you should be able to to convince them, but with data and with squeaky wheels.
Might need to be the last question.
Hello? I wanted to ask you, what was the time frame in terms of weeks or months for, if you could break it down into 3 parts, so the planning where you were doing the figuring out what to do, and you came up with the 3 plans, the 3 options, how long was that? And then the second thing, from that point when you presented it until the people with the money said go ahead and do the greenfield, how long was that, the convincing? And then the third one, how long was it from that point to actually get it running and in the prod and everything's up and running and the apps are in the thing and in the new greenfield prod? So like, what was it, 1 month for the first one, the second one was 2 months, and the third one was 12 months, something like that?
Okay, so I did answer a little bit of that previously. The assessment, the matrix of what the cost-benefit analysis and which of the 3 plans we should choose and all of that. I mentioned this was urgent, so that was a pretty tight timeline. We needed to get all of this data together. I spent some late nights coming up with numbers, figuring out how much things cost so I could present it to the people that were going to pay the bills. The second question being, how long did it take that decision to get made after that data was presented? That was, I'll say, a week. We had to make sure the correct people were around. We had to make sure they understood what it was we were trying to sell them. And that went pretty quickly. And then in terms of building out the infrastructure, that one was still a work in progress. I mentioned the POC that was ClickOps, mentioned the minimum viable platform, which was a work in progress, and soon to be adopting production workloads.
So it's still not.
It's still not done. No, I sadly had to leave before it got to see its day in the sun.
Can you just say, like, you know, weeks or months? Was that a month, 6 months, 12 months?
Before it was going to be up? Or
What is your estimate from when they gave you the money until it will actually be working 100% with prod for everything?
with prod for everything, I'm going to say that's probably a year and a half.
Year and a half.
Yeah, because every application, different. Not even slightly similar.
So a
not
long
using.
time.
Yep, a long
Long
time.
time.
You
Okay,
still
thank
have
you.
some spaghetti to unravel, but at least you're unraveling it
Okay,
to
thank you.
a clean pot.
And will the slides be available?
Yep.
Okay, thank you.
Thank you.
So like, first one was a couple of weeks, maybe the second one was a couple of weeks, and the third one, 18 months.
Yeah, and you figure we only had 1.5 to 2 people working on it because we still had to support the existing environment. So that always being the challenge.
Okay, thank you.
Thank you, Heather, very much.
Thank you.
Can you hear me? Oh, yep, it's working. All right, cool. On. Check, check, check. Testing, 1, 2, 3. Y'all hear me okay? Test, test, test. Check, check. Can you hear me okay? Okay.
Sounded better when you actually had it closer to your mouth. Yep, I got you.
Check, check, check. Oh my God.
Much better.
Boy, that's,
I'll bring it
y'all,
down over here.
I'm going to have to keep my voice down because that's too loud. All right, is that okay? All right, cool. Either way is fine. Okay. Who? I don't think so.
What did you need to do? Introduce them. What? Okay.
Hello. Hello, this is Thomas, and I believe he actually going to have a presentation related to Ansible. It's like a software stack that you write in YAML and actually produce various stuff. And I actually don't know what AW is. I hope he'll bring his secret sauce and enlighten you all.
Thank you very much. Yeah, yeah. It's basically a server for running your Ansible playbooks, although it's a little bit more complex than that. And I believe, I could be wrong, but I think we've got about like 5 more minutes, right? About 4 more minutes? 3 more minutes. All right, so I generally try to allow for any stragglers. So we'll just hang out for a little bit. How's that? Anybody got any good jokes? Thank you. All right, cool. So let's give it just a couple of minutes. I want to make sure that we allow for any stragglers. And I know, like, it's 5 o'clock, and I'm one of 2 sessions between you and happy hour. So I recognize that, and I promise I'll try to get through this as quickly but completely as possible. And just out of curiosity, is there anybody from either the AWX or the AAP team here today? Bummer, because I got a bone to pick. Oh, y'all are going to hear all my pops and, hang on a second, let me see if I can do this any less objectionably. There, there we go. I'm not doing the plosive, like destroying your ears. Yes, actually, with upstream, because upstream is driven by Red Hat, and they are moving in a direction that I understand, but frustrates the hell out of me. But we'll talk more about it. All right. And I made a whole bunch of animation changes in the last session while I was watching. So I guarantee you something is going to go sideways, and I'm probably going to get something flying in from the wrong direction or showing up that shouldn't show up. We'll just roll with it. So there's like a gigabit switch in the lectern here that's blowing hot air on my feet and making an incredible amount of noise. It's probably, since it's coming towards me, y'all probably don't hear it, but it's pretty impressive. Oh, can you? Okay, good. All right, we'll make the best of it. That's right, that's right. It's like a little foot massage kind of thing. But all right, so I am seeing that it is 5 o'clock, so we will go ahead and get started. So first off, thank you very much for coming, folks. I appreciate it. My name is Thomas Cameron. I am the Red Hat practice lead at Sparksoft Corporation. We're a company in the DC area who serves the federal government, specifically around healthcare. So if you're familiar with healthcare.gov, we are one of the contractors on healthcare.gov, so we do all kinds of stuff with, the Centers for Medicare and Medicaid Services, National Institutes of Aging, National Institutes of Health, and stuff like that. So even though I work with the federal government, We do good stuff around healthcare, so don't hold it against me. And we're going to be talking today about enterprise automation with AWX, and we'll talk about what that is in a little while. AWX is the upstream project from which Red Hat builds the product Ansible Automation Platform. So I'm going to talk about kind of how to get familiar with AWX because AAP, there are trials available, but it's kind of a pain and they expire after 60 days. So I want to show you how to get it up and running in your environment so that you can become familiar with Ansible Automation Platform because it's a hugely valuable skill set to have. Lots of folks are moving towards Ansible for automation. In fact, to get your RHCE exam, you have to, it irritates me because they teach you nothing about the underlying technologies like the NFS server or DHCPD or any of that stuff. But boy, they will show you how to write Ansible playbooks for automating those things, which I've always thought was a little bit weird. But, so, let's talk about what we're going to be talking about. The agenda is that we're going to do a quick introduction. I'm going to talk about what AWX is, the architecture, the installation, logging in, building your organizations, adding your users, setting up credentials, setting up a simple project just to test connectivity to make sure that your machines are responding and you have your SSH credentials set up and correctly and all that kind of good stuff. And then, so we'll set up the project, we'll ping, we'll set up your inventory, just like with Ansible. You know how you have to have an inventory file. Similar concept, but we're doing it server-based instead of on a per playbook perspective. We'll talk about how to set up SSH, set up your credentials so that you can log into the machines that you manage. And then I will talk to you about what a template is. And then I'll set up another project for Apache Web Server. And then I'll set up another project for MariaDB with a goal at the end of showing you what it looks like in the real world when you use AAP or AWX to run configs on your environment. So time permitting, I'll do a live demo at the end. I think everything should be fine because I spun up all my VMs, and it does take a little while to spin up your AAP or your AWX VM because it's got to spin up Kubernetes, it's got to do all the networking and stuff like that, so it does take a little bit of time. Now, just a little bit of information about me, just so that you understand why I'm talking about what I'm talking about. So as I said, I'm Thomas, he, him pronouns. I have been doing this since 1993. How many folks are under 31 years old? Oh, God. All right. So I've been doing this literally longer than some of y'all have been alive. I started out, and I'm dating myself, as a Novell certified netware engineer. Back in the days where you could run a server on a 386 or a 486. Then I went to work for Microsoft. Don't hold it against me. During the Windows 95 launch, and that's I became a Microsoft certified systems engineer. Then I went to work for Red Hat. Spent about 14 years there. Was a Red Hat certified architect, plus a whole bunch of specialty certifications around security and performance tuning and all that kind of good stuff. I got recruited by AWS. Went there for about 4 years and got all of the certs from there as well. So SA Associate, Security Specialist, SA Pro, and so on and so forth. And generally by the time I get done telling people all the stuff that I've done, the answer is you don't get out much, do you? Because I spend a lot of time doing nerd stuff, and that's cool because it works for me with my ADHD. You know, you hear people talking about the superpower of ADHD. You can hyper-focus on stuff, and there have been times where my wife has come in going, I'm getting up for the day. Have you been to bed yet? So yeah, it's a good thing to be a nerd with ADHD. So my contact information is up there. Don't hesitate to reach out to me. If it's community stuff, like what I'm doing here, which I absolutely love doing, my email address and my website are on there. If you want to talk to me professionally, you've also got my work email address. So whatever makes sense, I'm available. So as my daughter likes to say, Dad, you woke up and chose violence. I'm going to ask y'all some questions. I want to get the blood flowing. I want to get the juices going. I have a question for you. How do you pronounce this? How about, raise your hand if you say system cuddle. Okay, system CTL. Okay, cool. How about this one? Same? If it's cube cuddle, no? Okay. So cube CTL, all right, cool. What do you call this? Is it K8S or is it Kates? You call it Kates. Really? Okay, cool. And then finally, is it K3S or is it K3s? Keys, just keys. Okay, cool. I was just curious, right? Because I've seen some people call it, cube cuddle, and a lot of people call it cube CTL, and I was just curious, if that was just me. Now, finally, oh, no, never mind. I don't even want to bring that up. All right, cool. So let's move in to the meat of the subject. Let's talk about what AWX is. So AWX, as I said, is the upstream for Ansible Automation Platform. And this is literally from Red Hat's website, or the AWX website. And it basically just says, hey, this is where we put stuff out into the community. And this is one of the things that I love about Red Hat. That's why I went to work for them. Is that they really try to take an upstream first perspective. They're not always successful at it, but I genuinely believe that management's heart is in the right place. So as I said, AWX is the upstream, just like Fedora is the upstream for Red Hat Enterprise Linux, AWX is the upstream for AAP. The UI that you see with AWX is the same. I mean, there are a couple of little subtle differences, but one of the things that I love about using AWX is, like I said, you get the experience, you can play around with it, you can learn kind of the foibles and stuff like that, and you're not having to pay for an expensive subscription or do the silly, oh, I got to come up with a new email address for another 60-day evaluation. Not that we would ever do that, right? Right? Okay, all right. So, very high-level 10,000-foot overview of the architecture, because you could spend like two weeks talking about this. In fact, if you take the 394 test from Red Hat, it is literally like 40-something, 48 hours of training if you do the Red Hat online training. So, I mean, there's a lot to it. But the 10,000-foot overview is, it is Kubernetes based. There are a number of options. You can do K3S or what did you call it? Keys, okay. So you can use keys. You can use Minikube, but don't. You can even use OpenShift. There are a number of ways that you can do it. And basically what it does is there are containers for job management, there are containers for the engine for AWX itself, there are containers for the UI, there are even containers for Postgres, if you so desire. You can actually tell AWX to use an external database. That's totally cool as well, just whatever makes sense. But for what I want to talk about here, which is basically like just getting up and running and used to it, you can just let it build the Postgres containers. And again, this 10,000-foot overview, this is an advanced architectural diagram. So you can have, the automation hub, you can have the EDA controller, you can have the automation controller itself, you can connect to external databases. Like, it can get really big and really complex. But again, with AWX, it's really kind of designed more for just getting familiar with the technology. And so we're gonna take a really simple view in this session where we're just gonna do it on a single node machine and play around with it. So, like I said, AWX, there is a how-to in the AWX GitHub repo. It's terrible. Don't do it. It's seriously, it's painful. And I'll talk about what I ran into. So, but for single node, I tried on Fedora 39. I tried on CentOS Stream 9. I did one successful installation doing the Minikube, and I did one successful installation using the Docker Compose, in the developer thing, like 3 weeks ago. And I was like, this is going to be great, man, because, it worked all the way through. And then they revved the operator, and then they revved AWX, and it was awful. Everything broke. And so I struggled to get a working setup. I literally did not get my final slides done till last night because it was just failing and failing and failing. And I was seriously at the point where I was like, I may have to just cancel this talk because I couldn't get the demo to work. I finally settled on using CentOS Stream 8, and that seems to be the most stable build. And using the keys installation just worked, so that's what I did. I used Kurokobo's keys method. I tried using the AWX operator as it was described in the how-to, and Minikube it would come up and then hang. And it never would, and I was looking at logs, I couldn't figure out what was causing it, so I fought with that. Tried it on CentOS 9, same thing. Then I tried the Docker Compose developers build, and it wouldn't build the containers. It would throw errors about Postgres file systems, and that wouldn't work. And I was starting to get a little bit panicky there. And then I was finally on the Matrix channel for AWX, and somebody was like, dude, just use Kurokobo's keys build, it works. And I tried it on Fedora and it crashed, and I tried it on CentOS Stream 9 and it crashed, and I finally was like, oh my gosh, I'm cursed. This is never going to work. But it said in his documentation, I have tested this on CentOS Stream 8, and so I was like, all right, I have tried all my best thinking, and it didn't work. So what I did was I did a super minimal installation of CentOS Stream 8. To give you an idea, if you look at my DNF group list, you see everything is labeled as available. It was a super minimal installation. Nothing installed. The only thing that I installed was at base and at core, and that was it. So only about 576 RPMs. Now, if you go look at the URL, and y'all can have this slide deck, I will post it as a PDF on my website. But if you go look at the GitHub repo, you can dig down into the README, and it talks about, we're going to use the /data directory. You're going to set your passwords for both AWX and Postgres, et cetera, et cetera, et cetera. I was like, okay, cool. And then I read down, and it was like, I tested it on CentOS Stream 8, and I was like, okay, message received, and I did it on CentOS Stream 8. Now, interestingly, it does use a slightly old version, but just a few revs back of keys. And it does use an older operator. The 2.13.0 dropped last week. And as soon as you shut down your cluster, it deleted the storage for the Postgres server. So that was something I was fighting with. They did come out with 2.13.1, but even that one, somebody else on the Matrix channel was saying, I can't get my containers to build. And so again, I came back to this documentation. He's like, 2.12 is the way to go. And so that's what I did. And it uses an old version of Postgres, but it works. And so now I also looked at the requirements. 2 CPUs with 4 gigs of memory. 10 gigs for varlib rancher, 10 gigs for data. So I made sure that those were both there. And so, again, CentOS Stream, made sure that I had 24 gigs of memory because I was like, no, I want to make sure this thing's going to run and compile and all that kind of good stuff. It says you got to have 4 cores. I might have gone a little bit overboard, 16 cores for this VM. And made sure that, again, varlib rancher and data both had, I think, 20 gigs of space, and so I was good to go. Now, the deployment instructions tell you to do something which hurts my heart a lot. They tell you to disable Firewall D. Anyone ever seen my SE Linux for Mere Mortals presentation? Yeah. So, security guy, like, you want me to do what? But I did it. And then it has you remove some stuff just to make sure that it's, or to turn off some stuff, and then install Git and curl. So, again, I hate this advice. In the real world, I would probably, make sure that I set my firewall rules up. But for this demo, I went ahead and did system control disable firewall D. Make sure that those services are turned off if these are cloud instances. And then I made sure that I had Git and curl installed. That was installed. We're good. And in the instructions, it said reboot. And I was like, you know what? I am cursed, so I'm going to do what the instructions said. And I rebooted the machine, and it seemed to be just fine. So I totally understand why it installs this way, but I'm just curious, does anyone else hate mixing packaged software and stuff like Flatpaks and snaps and all that stuff? Because yes, I really want 3 different distribution mechanisms to manage my 10,000 servers, right? I hate that. Yeah, I'm looking at you, Snap and Flatpak and all those guys. So then it talks about installing keys. And the way that you do that is you use curl, pipe it to bash. I hate that. But again, we're doing this for a demo. I ran the command. One of the things you want to remember is make sure you tell it what the mode is for the config file, because by default it's 600 and it's owned by root. And as a regular user, you can't read the file and you can't start your cluster. So make sure you do that. It will then create a bunch of symlinks, including there's a kill all script. There's the service file that it gets that it generates and then does system control enable. So that's kind of nice. That means that when you reboot the machine, all your services come up and it actually works as expected. So that was really cool. And then once I ran the installer, I mean, it installed pretty quick, right? And I was like, oh, cool, it's up and running. And I did kubectl get nodes, and I was like, okay, yeah, it's up. But then I remembered, oh yeah, no, it's got to spin up all the pods. And so you could see that for the first several minutes, it took probably 10 minutes for my machine to come up. You can see that it was doing container creation. I use watch with a 10-second delay, and I just ran it until everything was either up or completed and expected. So I was like, okay, cool. It's up and running. We're in good shape. The next step is I need to use AWX operator. And the way that we do that is you got to do git clone. You got to go to the directory, check out the correct version, and then run some commands. So I created a git directory, went to that git directory, did a git clone. Once I did the git clone, I did the git checkout 212.2. That worked just fine. And then the instructions say, now we just use kubectl-k operator. And so I ran that command. And one of the things I love about this guy's documentation is it says these are the commands you can run to check and make sure that everything's working. So you kind of get to follow along and make sure that things are working the way expected. So I did kubectl apply -k operator, and you see all of these things that got created. And again, the nodes that was already up, but I did get pods, and you can see that again, it's doing container builds, so you got to wait for a little while. You can watch CPU utilization on your machine, and then after a little while, and I used watch again, and after a few minutes, all of my processes, everything was done, and my machine was up and running. And so then it even says, like, you can look and see all of the, everything. You do kubectl-n AWX get all, and it shows you your pods, it shows what services, the deployment apps, it shows all of this stuff, and so you can watch and see that it's okay. And then you need to make some customization for your site. So you go in, and first and foremost, and I love this about this repo, is he's like, let's go ahead and do this using SSL on port 443. We're just going to use a self-signed certificate, so you get the warning, but like you don't have to go, oh, I'm going to connect to port 30870 or something like that. You just go to the web server and it's good to go. So it has you set an environment variable, run your OpenSSL command, and then you have to make some changes in the AWX YAML file. And so I did that. First and foremost, though, I wanted to make sure that DNS resolution was working the way that I was expecting, and I found that I had done something silly. You know, when you're using DNS mask, when you define your IP addresses in your etc hosts file, whatever the first field after your IP address, that's what it assigns as a host name. And I had forgotten that. And so I had a little shell script that was like, you know, for I in 1 through 254 do echo host or the IP address and then host $I and then host $I dot virtual dot LAN, which is what I used for that. And it screwed up my DNS resolution in my virtual network because everybody was like, oh, my host name is host 123. Instead of host 123.virtual.lan. And it did screw up something that I was trying to demo, so just be aware of that. So I made sure that, you know, DNS is working, it worked forward, reverse, everything was resolvable. And then I said, you know, I used the command that it said. So I did AWX host is my host name. And once I made sure that that was set, then I ran the OpenSSL command so that I got the self-signed certificate. It wrote it out into a key file so that I could use for my web server. And then, yeah, I know I'm putting a key on there. This is the key for my virtual network in KVM. So, like, steal it. I don't care. Unless you get physical access to my machine. Whatever. So then it talks about you have to customize your awx.yaml file. And it's a pretty simple fix. So you go and you see that the default is awx.example.com. I knew that I was going to be using host 209.virtual.lan, so I just edited the file, made that change. And then it talks about you have to change the password if you want to in your customization.yaml file. And so I did. I went and I edited it. That's the file. It's under base. You can see that it had the default password, which is Ansible 123, Ansible 123. I just edited it, and I came up with a silly, 20 SparkSoft 24, bang. And I did that in both places. One is the password for the Postgres database. The other one is for the login. So I made those changes. It talks you through making directories. We've all done that, right? So I did want to show you, though, in the pv.yaml file, the persistent volume YAML file, you can see that it sets the claim up, allocates 8 gigs in Postgres 1.3, and then the other one is the persistent volume for /data/projects. It'll use 2 gigs of that space. So I made that. I did those things. I created those directories. I set the ownership per the instructions in there. One thing that I will point out is it says to do chown 1000. If your UID is not 1000, don't do that. Like, use your UID so that you own that directory. But I did that. I checked the permissions. Everything was good. And then finally it says go ahead and do kubectl apply -k base, and I did, and then it talks about some commands that you can run to see the progress of your build, and I did that, and I'll show you what that looks like. So I ran kubectl apply -k base, and it started all of those containers, and I watched the log files, and man, it took like 15 minutes. And I've got a fairly beefy laptop. It's fairly new. It's got like 12th gen, I think, Intel. Like, it's a pretty snappy machine, and it still took a while. So watch the log file, because nothing's more exciting than watching a log file scrolling by. But it also talks about, some things that you can do. So I would watch, kubectl get pods -a, and you could see what was, coming up, and you could see what was in the AWX namespace. Watch that for a little while, came back to the log files, because it was still scrolling by. Open another shell, did get pods, and you could see that, there were a bunch of them that hadn't started up yet. I just did a watch command on the kubectl in the namespace of AWX, and I just watched it. And after a few minutes, it finally converted over, and you saw everything was up and running. I was able to do get pods-a, and I could see that initially, everything was initializing. After about 10 minutes, it came over to where everything was running, or it had completed and exited. And then once I was sure that it was done, I could use kubectl-n AWX, and you could look at everything, basically, your all ingress, secrets, all that kind of good stuff. And so, again, this just shows you that, yes, everything came up. It'll tell you what port numbers are exposed. It'll tell you, whether your deployment apps have completed. So it was pretty cool. The instructions, like I said, were really good for this keys deployment. So did that. Finally, went back to the command where I was watching the log file, and this is the thing that you care about. When you see the recap at the end, you just want to make sure that failed is set to 0. It will skip a bunch of stuff based on what your architecture looks like. That's cool. As long as you don't have anything failed, then boom, the system is up and running. Now, spent all this time trying to figure all this stuff out, and then we were able to log in and start using things. And that's where the meat of it is. So, went to connect, same as you've always seen. It's a self-signed certificate. It says, hey, this is not to be trusted. Okay, whatever. Thank you, Google. Log in using the username and password that or the password that you define. The login is admin. And then you get the dashboard. And you can start poking around in there. There's a lot of neat stuff. But we're going to talk about sort of the minimum necessary things that you need to do to start playing around with the UI. So the first thing that I did was, I don't know if you can see it up here, I went to help about, and it says that it is 23.9.0, which is the latest version of the build. I went to the AWX repo, and sure enough, the last stable version was 23.9.0. So cool, got the latest version, good to go. Now, once you're logged in, what you need to do is start to set up what you want your environment to look like. So what you could do is you can set up your organizations first, and the way that you do that is pretty straightforward. You just go over here under Access, go to Organizations. There's a default organization. I do recommend that you not just use the default organization. It's kind of one of those best practice things. Like you may be in an environment where I know for sure we're never, ever, ever going to have another organization. Sure. What? Somebody squeaked. We're not all staring at you or anything, I promise. So go ahead and define the organization. Don't just use the default. So I go in. It's real simple. Click on Add. Put in the name of the organization. I work for Sparksoft, so I made an organization called Sparksoft. I gave it a nice, pretty description, and that's it. Boom, you've defined the organization. Now everything that you do will be associated with that organization, all your user accounts and stuff like that. If at some point down the road, all of a sudden you acquire a company or you get acquired or something like that, because you've already set up your organization, you're not as likely to run into the oh no moment where, oh, I got to burn it down and start over from scratch.
What happens if you don't do that and then later there is a change?
It's not a huge deal. Generally, what you'll do is you'll have to do a little bit of work. You'll have to basically create new inventories and create new users and stuff like that in the new organization. But beyond that, if you have a really super complex build, you're probably going to have a bad day. Because there's so much stuff that gets poked into the database, like your users and your credentials and stuff like that. You're probably going to have a tough time with it. So try to, if you can, just build your organization, from the outset.
If you did the default organization, can you rename that to a named organization?
Ooh. I don't think I've ever tried because I always just ignore the default and create a new one. I don't know. I don't know. I'll play around with it. I'm going to do a demo in a little while. We'll take a look. I don't know. All right. Now that you've defined the organizations, you got to create users. Pretty straightforward. You go into the UI, go over under access, go to users. There is the default admin user. Just click on add. You'll get a form that looks like this. You're going to put in name, first name, last name, email address, the username. You could define the password. And here is where you have the opportunity to set access levels. Right? Do you want to do a normal user where you're going to have to explicitly be granted permissions over an org or over a work group or something like that? Do you want to be a system administrator, which means you have, godlike privileges, or you even have the ability to have a system auditor type of account. So someone can go in and take a look at what you've done, but they can't make any changes. So set all that up. Make sure you assign it to the correct organization. Life is good. Lather, rinse, and repeat for all the people in your organization or in your IT team, right? Pretty straightforward. So when you get done, you'll see the users in there. Life is good. Now, this one, it took a little while for me to wrap my head around what we were talking about here. You can set up, and this is, I think, I don't know if I would say it's a UI bug, but it's kind of weird. When you go to credentials, you have the ability to define credentials for outbound communications, like to GitHub or any of the registries that you want to attach to. But you also use credentials for inbound communications to the systems that you manage. And the first time I was like, shouldn't that be too different? But we're going to go with it. So in this case, I have a GitHub repo. If y'all look at my GitHub repo, I'm not a developer. Understand this. My YAML code is ugly. I know it. You know it. Everybody knows it. Please don't say, oh my God, dude, what were you thinking? All right. So what I'm going to do, though, is I'm going to set up so that I can pull stuff from GitHub. Now, my repo is public. But there are a lot of people who have private repos, and you can't just do an HTTPS connection to them. You have to use SSH. So let me show you what that looks like. So I'm going to go into my credentials. I'm going to click on Add, and I'm going to say what it's called. I'm going to put a description in it. In this case, this is Thomas's GitHub repo. It could be my corporate repo, whatever. Assign it to the organization. Choose the type. There's a huge drop down that talks about all kinds of different types, whether it's like upstream repositories for containers or whatever. But in this case, I'm going to say it's a source control repo. I'm going to get the username and password that I log in with, and I have to put my private key into AWX or AAP. Now, I recommend that you create a separate private key that's not like anything that you use anywhere else for security standpoint, right? So if you have an SSH password for or a passphrase, I should say, just put it into there. Then down at the bottom, or no, that's it. Then you set that up. We'll test it in a minute, but this is basically saying, if I want to be able to SSH into a private repo on GitHub or whatever, this is the private key that it's going to use. Then you have to upload the public key to GitHub, but it's public key. You can do anything you want with it. So I've got that credentials set up. We're going to come back to credentials in a little while. Now, what I'm going to do is just to test to make sure that all of these moving parts are not grinding any gears. I'm just going to set up like a really simple Ansible ping. And so what I've done is I have to define a project. The project is going to be what is used to go fetch that content. So I'm going to find my SSH URL or my SSH command to grab my Ansible ping repository. And then I'm going to go into create a new project, give it a name, give it a description, assign it to the organization. And I'm sorry, this is small. I did 1900 by 1280 or whatever it is, but I should have made my fonts larger. I apologize for that. But assign it to the organization, tell it what type of source control it is. In this case, it's Git. Here is the source control URL, which is actually just a login. And I chose the source control credential as being the type GitHub. And there are some check marks that you could do down here, like do I want to clean out the old version before I pull a new one, or do I want to just delete the old version? There's a bunch of things you could do. For the most part, unless you really know what you're doing, like you can leave it blank. Just read the context sensitive help. You can click on the little link next to it and it'll explain those to you. And when you complete that, it's really important that you see that right here it says that it's running the sync. It's going and fetching that stuff from GitHub. You got to wait till that turns green and says that it was complete. Otherwise, you have a problem with your authentication or something like that. But after a couple of seconds, that'll turn from running to successful. When you see the green, you're good. You have pulled your content from GitHub. And there it shows up. Yep, there's Thomas's Ansible ping project. This is the project is where you go and get your content, your playbooks. Now, just like in Ansible, when we have an inventory file, right? You have to have an inventory file that's going to have, your host names, and maybe you can group them together into web servers or database servers or dev, QA, and prod or whatever. We can do the same thing, but we don't have to do an inventory file. We just define the inventory inside of AAP, or in this case, AWX. So, what machines do I want to run this ping test on? Well, I'm going to set it up. I'm going to go to inventories over here under resources, and you're basically just filling out the inventory, the systems you want to be associated with, whatever it is you're doing. So I'm going to click on add, choose add inventory, give it a name. In this case, I said this is all of my WordPress servers. This is the database servers. This is the back-end, the back-end database servers, the front-end web servers, whatever. So I give it that, associate it with my organization, and that's really all you need to do. Then, once you've defined the inventory group, then you're going to come over here to hosts, and you're going to start adding hosts to that inventory, just like if you had edited your inventory file. So I'm going to say I've got host 183, and then I'm going to add host 120, because 120 was my database server, and 183 was my web server. So I put both of those in there. Now I've got an inventory for that one thing, for my ping test, right? Once I've got the inventory defined, now there is a break that I want to make. Y'all probably know this, but I just want to make sure that it's really clear. You have to set up SSH, right? Remember that Ansible is going to log into your machines using SSH, so my recommendation is that you do SSH copy ID, or what I do is when I kickstart my machines as part of the post-install process, I write the authorized keys file. Normally, like I said, I build it with kickstarts. I add that remote user, sysadmin or Ansible SVC or whatever. I generally do it with no password so that no one can ever log in using a password. And I just make sure that I've created the authorized _keys file in that service accounts directory. And the beautiful thing about that is that machine could be physically on the internet with no firewall rules. No one's ever going to be able to log in as that user because you haven't assigned a password. You can only log in using the SSH key. But in this example, I just want to kind of go over what it looks like. So in this case, we do SSH keygen. I chose ECDSA, created the file. Look at the permissions on it. Notice that the private key is always read-write for the owner only. The public key, we don't care. Anybody can have the public key. That's not a big deal. So make sure I know those permissions. Then I do SSH copy ID with that ECDSA key over to whatever the machines are. And I did it on host 120, and I did it on host 183, so I made sure that those things were there. And then we're going to go back to credentials. Remember I said earlier, credentials is, you could do one set of credentials for logging into GitHub, but now what we need to do is we need to tell AAP or AWX about how it can log into your systems. So I'm going to go into credentials again. I'm going to add a credential. There is my private key. Again, this is on a virtual machine that I'm going to destroy after this demo is done. But I get the private key. I go into and create a new credential, and I called it, sysadmin's SSH key, give it a nice description, associate it with my organization. The credential type in this case is a machine credential. In other words, I'm logging into an OS-based machine. There in that drop-down, there are things like network devices. There are services for doing like info blocks and stuff like that. So there's a ton of options that are available there. But again, we only have an hour, so I just wanted to talk about kind of the nuts and bolts. So I define the machine. I can also put in the sysadmin username and password. In this case, again, I don't use passwords. I only use SSH keys, but you can do that. I put my private key in there. Down at the bottom, you remember how in your Ansible.cfg, you have to do things like what the remote user is. You have to choose whether you're going to become or not. If you're going to become, how are you going to become? So same type of deal here. We are going to become. We're going to use sudo. We're going to sudo to root. So just like you're used to in your Ansible.config, this is just putting it in a GUI, and you don't have to do a new inventory for every one of your projects. So that's done. Now I have my SSH key that's been defined inside of AAP or AWX, and there it is. Now I've got to set up my template. Templates are not playbooks, except they really are. Really what you're doing is the playbook that you've checked into GitHub or whatever is going to be downloaded and put into your library in the AWX or AAP machine. So just remember that when you create your playbooks, don't do anything like I uploaded some playbooks that I was only running against my database servers. So for the hosts, it said DB, and I tried to run it on here, and it was like, I don't know what that means, and it failed. So always set them up to be all, and you can get super crazy with your playbooks. You can get really sophisticated. You can use Ansible roles. I mean, there's a bunch of cool stuff. But again, because we only have an hour, I'm going to keep this really, really simple. So I go into my templates. I say I'm going to add a job template, give it a name, give it a description. The job type in this case is we're just going to run a command, right? I can associate it with my any of my inventory groups. So in this case, I chose all of my WordPress servers, all 2 of them, associated it with the project that I synchronized from GitHub. And I don't actually have to define an execution environment. The default execution environment that it sets up is usually fine. If you go out of your way to define other execution environments, which unfortunately is kind of out of scope for our 1-hour thing, you would define it there, but you can leave it blank. Now, something that's really cool about setting up a template, you get a drop down for the YAML file that you want to use. I'm going to come back to that and show you something that I think is kind of cool, but right now, the default is it's the ping.yaml file that I checked into GitHub. I can associate that SSH key, the sysadmin SSH key, with credentials. Then, down towards the bottom, even though we're just doing a ping, I just want to make sure that Ansible is working on the target machines, you could do things like, do I want to do privilege escalation for this? In other words, do I want to become root? And I checked the box, and I said yes, because I want to test to make sure, not just that it's pinging, but that it does privilege escalation, all that kind of good stuff. Do I want to enable concurrent jobs? Abso-freaking-lutely yes, especially if I'm running this across, 1,000 machines. So there's that. I save that, and now it comes back and it says, okay, it's using this playbook, ping.yaml. and it gives me the option to either edit the template or run the template. And so, hey, it's time to test. So I click on launch. It runs just like if you ran Ansible Playbook from the command line or Ansible Navigator from the command line. This ought to look really familiar. And so basically what it does is it runs the SSH session to the target machines, and you can see that it gathers it up, and it says the events processing is complete. So at this point, we know that our SSH key is good. We know that we've pulled the YAML file. Like, life is good. Now, if we want to get a little bit more sophisticated, and this is just showing that when you get done with one of these jobs, it'll show up under jobs, and so you can go back and see. This is a great tool for if you did something wrong or if you fat-fingered something. It'll come up and it'll say, it'll show you what the Ansible run output is. So there's that. Now let's get a little bit more complicated. Yes, sir? Oh, like under the hood? I don't. What's that? Okay, so yes, it is actually running it in a container in your Kubernetes cluster. And the reason I know that is this confused me because I'm not the sharpest tool in the shed, and I'm the first one to admit that. Let me go back and let's see, where to go, hang on. Let me see, whoops. Oh, it's actually in a much previous slide. So the reason that I know that it's running in a container is when you define the project, and the project is where it goes out and actually fetches the playbooks, it says, oh, this is being stored under varlib AWX. I was like, ooh, I want to see what that looks like. So I logged into my AWX machine, and I looked, and there was no directory called varlib AWX because that runs in one of the containers that is running in the Kubernetes cluster. So what you would have to do is you'd have to use kubectl to log into the container, and then, so yes, it is definitely running in a container. Does that answer your question? Okay. What's that? Okay. Let me finish up, and then we'll do questions at the end. All right, cool. So we did that. So again, this is just the same thing, except now my playbook is a little bit more complex, right? Let me show you what that looks like. So I'm going to go in. This is and again, y'all, don't bust my chops for my crappy YAML. So I went to my repository, github.com/tdcam, and there is my apache.yaml playbook. I went to create a new project, because remember, the project is what fetches the content. So it's Thomas's Apache installation, organization, it's a Git source control type. There's the URL, which is actually an SSH login. I click on that, it synchronizes, so now I know I've got my playbooks. Then I go over to the inventory, and I'm going to create the inventory. So I create a new inventory. I say this is for the web servers. And when I fill that out, I go over here to hosts. I add my hosts. In this case, it is host 183.virtual.lan. It's a VM on my Linux laptop. Once I've got that done, life is good. I go over to the template, and again, the template's not really a playbook, but it kind of is a playbook because it uses the playbook that you got. Define it. I'm not going to go through all of this because you've already seen it, but it's a run job. I'm going to say it's on the web servers, and it's using the playbook that it pulled down. I am going to make sure that I choose privilege escalation and concurrent jobs, and I'll usually... Well, sometimes I will enable fact storage because, when Ansible does a connection, every time it does, it gathers facts about the machines. Do I want to keep those facts on my AWX server? More data is never a bad thing, so yeah, I do. So I create it. Now, once I've created the template, I can click on the template, and this is what it looks like. So I go to the template, I click on launch. It logs into my machines, and so what I've done is I set up a DNF call, or a DNF function. So I installed the HTTPD and mod SSL, and I think WordPress. So I made sure that those were installed. I made sure that I started the service. I opened 80 and 443. And when I get done at the end, nothing failed. So now my web server, my web tier is up and running. And so sure enough, I can go to host 183 and yep, it was successfully deployed. I actually, as part of the playbook, created an index.html that says successfully deployed. Now, this is something that I'm kind of a geek, and so like I don't like leaving messes. So I actually updated my Git repo with I had the Apache install.yaml file. Well, I have an Apache remove.yaml file. And basically, I'm not going to bore you with it, but basically what it does is it goes through and it removes HTTPD and mod SSL, turns off the firewall ports, and so I can create another template for that, or I'm sorry, I can go to the existing template for that. And you remember I talked about how you've got the drop down? Well, I've got my apache.yaml, which installs everything, and then I've got my remove apache.yaml, which does DNF auto remove, so it's not just the package, but all the dependencies and stuff like that. So I created that, run that, and so I can back out what I've done so that the machine is exactly like it was before I installed. Now, y'all know that that's a pet's approach, and we're supposed to be dealing with cattle, but I just thought it was kind of fun. So there's that, and after I get done, the web server's not there, so all of a sudden that's failed. Same thing for now the backend server. I'm going to go through this super quickly because you've seen it, but I go through, I get my my repo, I create the project, make sure that it's been synchronized, and then I've got that, the project. Now I associate it with the inventory, which is just my database server. Again, y'all have been through this, so I'm not going to spend a lot of time onto it. Define the inventory group, add the machine to it, which is host 120. And once I have the inventory defined, then I can go and create the template, which again, it's just another YAML, it's just another playbook that I checked in to Git. So I go in, define it, associate it with the database servers. Now right now there's only one, but you know I could adjust that inventory to be 10 or whatever. Check the box again to make sure that we're doing privilege escalation, and once that happens, I run it, it goes out, it installs the MariaDB server, it starts the server, it opens up port 3306, and it even runs a little shell script where it reads a SQL file so that it creates the WordPress database, creates the database user, like all that kind of good stuff. And that brings us to what I would say is kind of the minimum you need to understand just to get familiar with AWX. As I said, if you do the Red Hat Online Learning for this, I think it's like a 48-hour class or something like that. So, you know, clearly I can't cover anywhere near all of that in here, but I just wanted to give you a resource so that if you want to play around with this, that you can, okay? So let's do this. What does this look like in real life? And you gotta love live demos. So is this the real life or is it just fantasy? Let's do this. Let me bring up my web browser, and this is gonna be a challenge because I'm gonna have to do my web browser like on your screen. Hang on just a second. Or actually, what I could do is, let me see if I can just mirror this. Give me just a second, y'all. So, let's go to settings. Let's go to display. Let me change this so I'm mirroring. This may get ugly. Stand by. Give it just a second. All right. Can you see? Yes, you can. All right, cool. So, as just kind of a what's going on. I'm going to fire up a couple of shells. Give me just a second. So let me make this a little bit larger so y'all can see it. There we go. And I'm going to do two of them. So I'm going to do SSH host 120. And then I'm going to do SSH to host 183. And what I'm going to do is I'm going to pop this over to another desktop, and we'll come back to it because this will kind of make sense in a second. On that other desktop, I'm just going to do while true do psax. And I'm going to leave those running because we're going to pop back over to this in just a second. All right, so we're just doing a process listing over here. I'm going to pop over to here. I'm going to log into my AWX instance. And like I said, let me make this a little bit larger so you can see it. Can y'all see that okay? Okay, cool. All right, so again, I'm going to go into my templates. I have set up my inventories. This is my inventories for inventory for the database servers and the web servers. I've created projects for the Apache installation and the MariaDB installation, and I've created templates for each one of those. So let's say that we want to install MariaDB. Now, I only have this defined on one machine, but again, you can run this on as many machines as your system can support. So I'm going to go into MariaDB, scroll down a little bit, and this is how difficult this is. So I'm going to fire up that, and I'm going to pop over to here to host 120, and you'll see in just a second, because it's just doing a loop of all of the commands. It should, hold on. I love live demos. Why? Hang on just a second. That is obviously not happening. Hold on just a second. Let me cancel that. Let me make sure I didn't screw up my project. Let me make sure I have network connectivity. So let me do the MariaDB installation. Let me sync this and make sure that I've got connectivity. Okay, that worked. Let me try this again. Templates, install MariaDB, launch. Come on, you got to be kidding me. What's that? Oh, there it goes. Okay, it took a second. This is why live demos are always like, all right, cool. So, but you can see, and I'm going to pop back over to here, and there you go. You can see that you've got a bunch of processes running in here. A bunch of stuff gets fired up, and after a few seconds, hold on, I saw it. There we go. MariaDB is running on that machine. And on that machine, because I did run a SQL script on it, so let me do this. I'll do MySQL, select star from MySQL.user, and look at that. There is the user. Hold on just a second. Right there. So I defined the correct user from the correct machine, so WP admin from that machine. And so I can go back over to the UI, and I can see that it completed successfully, and no errors, no nothing like that. So if I go over to my web browser, and I go to host, no wait, never mind, that's the database server. There's no web server on there. Let me do the other one then. So now that we got MariaDB running, I can go back over here to my template. Now I can do the install Apache command. Click on launch. Hop back over here to this machine. And hopefully, there we go. See how it just changed? And you can see a whole bunch of jobs being run on the back end. And in just a second, what it'll do is it will have the web server and the PHP service running, and hopefully, yep, there we go. So I got PHP FPM, and I've got Apache HTTPD, And hopefully if I come back over here and I look at my output, boom, there we go. No errors there. So if I go to host 120 dot virtual dot LAN, oh, come on. Host 120 dot virtual dot LAN. Slash, there we go. Oh, I'm sorry, it's 183. 120 is the database server. Sorry, guys. Let's do the right thing. 183.virtual.lan. There we go. So now the web server's up, it's working. And if I go to WordPress, WP admin, check it out. It's already got the database connection to the machine on the back end because I deployed the wp-config.php file that had the right database connectors using Ansible. So now you just saw that I set up a database server and a front-end web server. This could have been load balancers. This could have, I mean, it could have been anything, right? The caveat that I have is when you deploy your machines, whether they're VMs on, VMware or on KVM or on EC2 or whatever, just make sure that you've set up your SSH key. And the beautiful thing about it is once that happens, once you've got that SSH key, obviously you have to be smart about setting up your firewall rules so that no one can SSH into your environment if it's out in the public except from your machine. Oh my gosh, I'm over, guys. I apologize. I'm way over. So this would be Q&A, but I got people over there that are kind of glaring at me. So was this helpful? Did this talk y'all through it okay? Because I tell y'all what, I beat my head against the wall forever to make this work. So hopefully this is helpful. I apologize. I'm like, I thought I still had about 10 minutes left. So again, let me do this. Let me pop over to, hold on. There we go. So again, if you have any questions, catch me afterwards. My contact information, like I said, is up there. You are welcome to reach out to me. I don't claim to be like the best, playbook author, but on the infrastructure side, this stuff I know relatively well. So thank you very much. I appreciate it, and have a great rest of your weekend. Yes, I already created the PDF, and I need to give it to SCaLE, and I also need to post it on my website, camerontech.com, and that'll be within the next hour or so. Yes. Hang on just a second. Hold on. Oh, that's not it. There you go.
never said I was an AV person. Yeah. I'll talk. Test, test, test. Oh, wow. Hot? You think, yeah. All right. Let's see. We're doing it like this. We're gonna look all cool, right? No. Oh gosh, hair. Yeah. Is it? Like this? Left hand side? All right. So I'm doing like a Britney Spears thing. Mm-hmm. Like, my ears be here. Okay. I didn't think this would be the hardest bit. I mean, like, RT, does it look stupid? Okay, cool. Oh, good. Okay, well, as long as I'm nice and crisp and fresh for you. Okay, okay. Yeah, sounds good. Yeah. Oh yeah. Yeah, these are my buddies. So yes, I'll let them be. Yeah, and so that would be with the microphone. I'm assuming I'm not gonna have the headset. Okay. Perfect. Perfect. Okay. So. Oh. Oh. I love a dim setting. Is it controlled? And then. Yeah. Looks like Ryan is coming to investigate. There is, yeah. Oh, that's great. Everyone can see all right these slides? Great. All right. All right. I'll sort of put this. Oh gosh, I don't have a belt loop or anything, so we'll just put this right here. All right. Okay. I think I'm properly hooked up. Yep. Okay. Now I'll stop fussing with this one. Now I'll fuss with a bit. Okay. One more fuss. Okay. All right. How am I sounding? Everyone here? Oh yeah, great. I also naturally project, so yeah. But I'll give some mic love. All right. Why don't we get started, y'all? Why don't we get started? Hey, so you're at this talk. So let me ask you this: like, who does this for a job? Yeah, show of hands. That's what I want. So like, y'all work with production systems in your job. May I have some job titles, please? Just shout out anybody's job title. Cooler the better. DBA. Yeah, systems engineer. You got any any network engineers in the house? No, mad respect for network engineers. Anyways, glad to have y'all. It sounds like we all have a pretty good idea of, next slide. We all have a pretty good idea what production is, and so I'm gonna skip all that part. And the difference between the production and your test, your home, your dev, your lab system, your, punching bag. So when you have an issue at home, what do? Well, you could restart restart the whole node if you wanted. You could, I mean, just putter. You know, it works sometimes. We all need to be cleaning our cases more often. You know, I don't know what's causing the problem. As you do, as you do, as you do. Yep. Or maybe it is just time for an upgrade anyway. You know, let's use that excuse. Production, our job, our data, our livelihood. No, can't, no, wrong. I'm gonna get you fired. So, it would definitely get me fired because this is not any of my stuff. This is other people's stuff. So I'm a systems engineer at Linbit. I work with high availability clients. So they have clusters of highly available storage that they need to fail over. And we all know it. This isn't a talk about DRBD or Linbit, by the way. This is just too bad. That's just context for what I am doing, and it informs my need for knowledge on performance and how to troubleshoot, etc., diagnose those issues so that I can help out the people that have these systems. They also have other clients that they will make available their infrastructure for. So by the time that I am getting a support request from them, I mean, there's some definite zeal for that issue to be resolved. Yeah. All right. Yeah. Oh, I guess I did put, so that you'd be able to know what an HA cluster is. But again, this is see me in the booth tomorrow if you want to know about that. All right. So do you ever look like, run to anything like that, and you're just like, so these are numbers, but are they good? I mean, is that all right? I'm breathing. All right, so it's gonna go way over here, because I'm pretty good at projecting. Yeah, I mean, is 5 good? So it's unfortunately a little bit complicated of a question, because it depends on your hardware, it depends on your network, it depends on your workload itself, your application, your SLAs. There isn't a good answer for it, so you can't just go Google, is it good number? It's just too hard of a question. But I'm hoping that I can establish today for you some direction towards, is this gonna be good, or how can I make it less bad at least? All right. What slide I have next? Yes. So, I'm going to give us a few rough concepts and methods for how we're going to be doing this. And then I'm going to dive into, I have 6 demos for us, live terminal demos, that they're going to use those sort of concepts, and we're just going to go through them. They're imaginary scenarios, but they are based on true stories, things that I experience day to day as I support HA clients at Linbit. So hopefully we can learn along the way. Oh, yeah. This slide seemed a little empty, so I just needed to put a little graphic there. All right, so overhead. I mean, it's not that. Overhead is what we have when you have maybe ran top or something like that, and it's going to be costing you processing power as well. The performance impact to actually gathering the metric, which can be difficult because you can't stop on a production system. Yep, so there's ways that you can make it better, make it worse. I can't just be coming up in here, running a bunch of S traces and just being like, yeah, I mean, I'm going to get some data. It's not going to be good. I just wanted some examples, so I mean, just here's top. One of the slides look good. And I circled it. So, one of the ways that we're going to rely the most on in diagnostics for production system, they fall under observability, which is observing the systems as they are, where you're not simulating anything, you're not applying any sort of test workloads. So all those metrics that are static to the system, they exist, and you can just peel them out of there. This also can apply to static configuration. Yeah. All right. But sometimes that isn't enough, and we will actually have to do some benchmarking. Oh, yeah, I guess this is yeah, if you're just catting, like, the pressure statistics for CPU, that would be an example. Yeah. Pressures. All right. So micro benchmarking. That's going to be a lot better than macro benchmarking. It is taking a component of the system, so something within the data path, but not the entire application workload, and it will simulate it, and yeah. But it would be an example like you are running some packets across the network. It's going to have lower overhead than just doing, like, whatever your application might be, simulating that entirely, and then saying, I don't know what's doing it, but I'm just going to apply that application again and again. That's not going to get you any closer to the diagnostic of the specific thing you need to improve to get rid of this bottleneck. Macro benchmarking definitely has its place, and sometimes you need to do a mix of the two, but I would say you're going to want to, if you can get some observability metrics, then we want to go for some micro benchmarking, some targeted micro benchmarking. But yeah, you might need to do some macro benchmarking. This one example, I mean, ping is technically an example of a micro benchmark. It's a little one, lightweight. Oh yeah. So yeah, it's a simulation. This isn't, macro benchmarking wouldn't be where it's just running in prod and you are observing it. You are applying it in this case. You are applying a workload yourself, and then you are checking on how the system performs based on that. All right. Yeah, I said all that. All right, well, I mean, I guess I wanted to demonstrate a little bit for each one, and then it was just like, okay, yeah, you based on that, all right, well, here's how it performed. All right. In order to do that, sometimes you're going to have to characterize the workload that you have, because not all IOPS are created equal. You need to know how your application is impacting the system, the qualities that it has. This is especially nuanced when it comes to storage. There are so many aspects to storage that I'm so excited about that we'll get into later. But they will have immensely different results in the system. They might look similar, but there's a lot of different qualities of them that you can just admire the nature of. Once you can break that down, you can do more effective micro benchmarks that are actually going to be reflective of the workload you intend to put on the system. All right. I needed this application to be a little more explicit so that I could decide that I needed that block size. And so this one just happens to tell me that it writes 512 sequential bytes to the disk, and so I am doing a DD that has a block size of 512, and then I'm writing it to the disk. Performance tuning is what we would want to do kind of last with our production system. That is what you'd expect. It's changing things and seeing if it makes it better. That's something that I would probably do right away at my home lab. I am going to really narrow in on what I'm trying to do because you also could just, you're going to be impacting your day-to-day money machine, you are probably going to be getting different results, and you're going to be confusing the issue if you do not target it first, and you don't have a diagnosis first. You don't have a specific component that you're zeroing in on. You're just changing random things. You're going to confuse everybody. Yeah. So I guess I re-nice this as an example. Cool. All right. So, anyone familiar with the use method? No? Well, I'm about to tell you what it is. So there's a lot of methodologies you can use to diagnose performance bottlenecks. The one that is used most commonly in Linbit and that I find is my favorite that I'm going to zero in on today, that is the use method. And this was developed by Brendan Gregg. He was a performance engineer for Netflix, and he has written some really interesting things. Honestly, the book is great. He also has another book that he recently came out with, which is on eBPF, that is really exciting. I don't have time to get into eBPF today, but really nuanced stuff. If you want a deeper dive on this, I would definitely recommend. He also has some really good utilities on the website. If you just need good checklists, they're just super handy to have. And so it'll save you a lot of work. In case you wanted to make a checklist, no, you just take what he's already done. It's on his website. But its use is utilization, saturation, errors. I am going to go into what those all mean right now. All right, well, I guess I'm going to go into what a functional block diagram is first. So for every resource on the system, you want to know what you iterate on for each thing. Oh yeah, this is the one we would use. This is from the DRBD user guide. That's a piece of software that Linbit supports. And this would be, it's an example of a functional block diagram. It's not a picture of the system, but rather a picture of the relationships and the components inherent to it. So these have drivers on them, but I'm looking at the physical hard disk here. You have the file system, the caches also, and then the service layer. So you can tell where everything is interacting. That'll help you. If you don't have this for a system, I recommend you draw it just to get started, or just ask your client if they have relationships like that, relation diagrams, so that you can have somewhere to start. But this is how you determine what your resources are that you're going to be applying the use method to. Continued. All right, so utilization, as it is defined within the use method, is the percentage of time that a resource, a component, like we saw in the functional block diagram, is performing work. So let's say we have disks, and they're totally idle. They are 0% utilized. We have some disks. They are churning, spinning 100% of the time. There's not a time that they're not active. They're not moving around. That is 100% utilized. But I want to be clear with utilization in this context, because with definitions it could be a little bit nuanced. A fully 100% utilized resource can still potentially accept more work. I don't know if I say that, yeah. Oh, well, saturation comes next. It's related to utilization, but let's say you have a CPU and it's waiting on disk I/O or something like that. It potentially could get a higher priority process that comes in, and it's able to move things around. And so because it's able to requeue things, it could be 100% it's doing something all the time. It might not necessarily be saturated. Just something to keep in mind. Saturation is related, but that is the time that a resource it has more work than it's able to process. And it's basically how much work it can't process. something to note about saturation and utilization and your interaction between the two. So let's say that you have a restaurant that is slow most of the time, but then you have a real banging lunch hour, and people are waiting outside. Yeah, you could have overall low utilization. That's just something to consider. We're going to see some scenarios later. Low utilization overall, you can still get peaks. Those peaks are important because they cascade through the system and can cause saturation, but then everything else is waiting for it. And yeah, just keep in mind those bursts can make a big impact. So even if you have overall low utilization. The E of it is a little bit easier. Errors. Don't really need to explain errors. I think we've all encountered one or two in our day. One of the quickest ways often to diagnose what's wrong with the system is say, what is it telling us? So ask it, look in the logs. Brendan quantifies these as like the number of errors. I don't necessarily do that because I can have a bunch of errors, but what are those errors can often be pretty important, not necessarily how chatty the logs are, because I feel like you could just sort of toggle that into a sort of thing. All right. Yes. All right. Now we're getting into some fun stuff. Let's get to demo number 1. All right. Oh, it's all dark now because my terminal's all dark. Great. Okay, so I'm going to set up a hypothetical for you. So I have a...
Sorry, can you increase the size of the letters? I can barely see it, but I think it's going to be a problem for the people here.
Yes, probably. Control plus. Oh, yeah. Is that true? I've got to find the plus sign. I have never done that before. Excellent. Thank you. Yeah, I would not have noticed that because I can see that just fine. Thank you so much. And if you can't hear me or anything like that, yeah, feel free to shout it out because I'm not going to notice. So just, yeah. Hey. All right, so this is a hypothetical scenario of, let's say that there is a client that I have, and they are running a DRBD cluster. So they have just a few nodes in a cluster. They have said to me, they have configured the instance, and they've said that they've recently seen some performance issues, and they believe that DRBD is the cause. They would like me to investigate. So, First. Oh, yes. Oh, yes. Oh, yeah. Don't look at this. Don't look at this one. I didn't want to run it early because I was afraid I was going to tank everything. All right. So I have my CPU one up. Oh, whoops. I did not have the other CPU one up. Control plus, right? Huzzah. A couple more times? If y'all don't know about Vagrant, by the way, it is super nice for if you need to just test some things. We use it all the time at Linbit, so you can just get Vagrant stacks that you just sort of you set them up in advance. Then you could use Ansible playbooks on them, so you can quickly configure some VMs to whatever use and abuse you have. And let me see, Vagrant. Search CPU 0. And I get in there. All right. So let's take a look at what could be happening. All right, well, what I want to point out here, don't look at the obvious, but what I want to point out here is some things about load average. So, load average, that number, is it a good number? It really depends on what your system is. How many cores does your system have? How do you find out how many cores your system has? You can, let me see what I got in here. I've been in the history. I saw this in the Ceph demo, so I kind of like it, where they sort of just have all of the command history, and they just sort of paste it in for themselves. Sorry. You know the demos never go right. Oh, yeah. I'm getting to that. I'm getting to it. Yeah, but I just sort of put the command history in, and then I could do all that, just so that I don't forget anything. So if we wanted to use like nproc, and we can uncomment that. Let's say we're going to use nproc. Okay, 8. So the load average we saw was kind of high for 8, because my stress ng is being particularly performant right now, which it wasn't earlier, but that's okay. Let's say that we wanted to use Lestopo. Oh, okay, I didn't install it, but maybe I should install it now. I think I need harbor lock GUI. Oh. Well, then I'm going to use harbor lock. Yeah, sure. This is nice because if you have systems with NUMA nodes, Lestopo will be able to show you a diagram of them in some cases. Otherwise, it'll look like this. It's good to look at the relationships between things and sort of make sense of the system. If you aren't in this system all the time and you look at a lot of systems, it's just really nice to get your head on straight on what the number means and what you're seeing when you dive into a system. Yeah, how many cores does it have? What is it? What are we doing with it? So just keep that in mind. You could do that. What else we got? Yeah, what did I say that we should do? Oh yeah, you can cat proc CPU info if you so desire. What we got for that? All bunch. But these are examples of how you can take a look at things. But yeah, we go back to top. Let's see if this has been distributed evenly. Maybe we can't really tell from this. Oh man, it's really tanking this guy. Anyways, let's go ahead and we want to see how this is being broken down by processor. So I want to take a look at the MP stat. You need the capital P flag for, and then we can take a look at so what we should have seen, my test might have just completed. So what we should see is, let's do a PID stat. Don't worry, we've got 5 more of these. Okay. So, notice all of these that are pinned to, well, what one might consider the 4th CPU, that is entitled 3 here. So let's imagine this isn't StressNG, and let's imagine it's somebody clever and they have their application on here. And then DRBD, usually it's pretty smart, and if you don't do anything to it, it's going to pick what CPU, it's going to pick what CPU it thinks is going to have the least impact to the system. It doesn't want to mess anything up for you. However, you can decide you do know better than it, and you said to it, I want a CPU mask of one processor or a certain subset of the many processors you have. 8, you might be less confused, but let's say that you have like 64 of them. That person might have said, they might have set the mask wrong. They said a set of CPUs that are going to be associated with particular NUMA nodes. Did I tell you what NUMA nodes is? If anyone doesn't know what NUMA is, that's non-uniform memory access. And just really simply, oversimplified, is the memory module is closer, just physically closer to the processor, a particular processor, so it's more efficient because it's just physically closer together. So you would want to pin it to particular parts. So you might think, okay, well, I want to do this because I want to make the system more efficient based on what I know about it. And this person made a mistake in this hypothetical. Because they made a mistake and they decide you can have an overall load average that is low, but you want to look at that particular processor breakdown to see if there is a particular one that has odd use. That's usually not going to happen, but keep those tools in mind to see what you've got. PidStat's a great one, and MPStat is one I like to use for looking at individual processors, what application is churning on each one. And if you intentionally do things with them, just, yeah, keep that in mind. All right. All right, I'm done with you, CPU. I'm done with you. I don't want you doing this anymore. Koi. All right. Do I have my history in here? Oh, I need to control plus all these. And Demo 2. Just so we know, we're moving on. We had enough of that. All right, let's see. Cool. So here's our second hypothetical scenario. We have a client. This isn't our machine. This is someone else. They might be in a different time zone. They might be halfway across the world. This is inconvenient for us because they write us email saying the system is slow, the system is not working, and then you come and you shell in when you should be awake and everything is fine for you. What do you do? Well, so they said the system, in this case, they said the system is being intermittently slow. We've got, we got replication speeds for DRBD slowing down at particular points. But what do we do if we take a look at, I don't know, top and we are seeing it looks fine? Well, let's set up SAR. So SAR is the System Activity Reporter. And yeah, it's make sure I have it in my history here. All right. I actually think I uninstalled it from this system just so that I can install it. All right, so it's part of the SysStat package, and at least it is for Debian-based systems in this case. You want to make sure that you enable it as well. You can't, you installed it, but we do need to enable it. So let's see, where do we go to enable it? I think I put it in here as well. Ah, yes. I am going to. Okay, well, it's not there. Oh, SysStat. Whoops. SysStat. All right. Okay, right now it's false. Great. Let's get on down here. Think you all have an idea of what's going to happen? I'll put this at true. You need to do that at least for Ubuntu. I believe you also need to enable it. I'm not sure, but we're going to do it to make sure. See if we want historical data. Okay, now we need to restart it. This is the initial setup. If you already have this running, this is just for your first time. And then you have it. Okay, now all we need to do is wait a day, right? So you got some time. Nah, okay, I have, just like a cooking show, I've already done it on this one. All right. So. Oh, yes, I forgot on the other one. In order to configure it, because I didn't even say that, this is how we configure it. It's just like cron. If anyone set up a cron job, it works identically, at least in Debian-based distros. So we are going to go into, let's see, am I gonna, where am I? Do I have it in here? I'm trying to use all of my things I prepared for myself, but I'm just gonna go into Etsy. And then Crondy. Alright. See, we got systat in here. It has already dropped something in. We just installed this. It already has that file in there. Oh, that's why I didn't put it in the command, because it already has it the way I want it. But I want you to look at it anyway, because just like you would expect, it looks like you would have in a cron table. For anyone that needs a refresher on that, we have for 5 minutes, every 10 minutes, and you have, I believe it is, what is it, month? It's a day, hour, day, month, 10 minutes, yeah, just all the time. Week, day of the week, yeah, and that's what it says. But that's what it means. And then it also rotates nicely for you, so you don't have to remember. But we have that, since I don't know more about the particular behavior, I just came into the system, somebody said it's intermittently slow, they didn't give me a capture of when to focus on. I'll just take 5 minutes every 10 minutes, sounds good to me. Maybe we can see something from that. So let's do that, let's just keep that at that. And let's see. All right, where did I put that? All right. Yeah, so it is, I actually would love for you to see, as much as I already had that prepared. Let me show you what varlog systat does, because that's where everything is kept. You can change how many are kept. Yeah, so I have since I set it up, how many days I have, and you can reference it by the day of the month in this case. And so if you want to reference, so what I'm doing here is I have a particular SAR command that I want to do. In this case, this is a network one, and I'm passing it to a file here. Yeah, we'll refer to the man page for more detail, but overall, just the general sense. This is the 12th day of the month, because this is when I set up this VM. But it has all of that information in here, and this is the return I get from that. It's real nice, because you can. Got all those. You just scroll around, and you can see that the 24 hours of whatever you just set up. All right. So let's see if we see anything going on here. Da, 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 da. This PM looks fine, looks fine, looks fine. Was there a question? Is there a huge jump? Are we still going up? Down the other direction. So there was a point of time it did shut off this VM, so that might be the huge jump that you're seeing. Yeah. 410. And then 420 over here. I'm still, oh yes, the huge jump. I thought you meant there was a skip in the logs, because that would have been obvious. I shut off the VM because so there was I was doing a lot of things that this is not. So in this case, it does look like there was some pretty heavy utilization during this time. This wasn't part of what I was doing. I was rerunning some tests at this point. That's why that showed up. Okay, but this is what you would look for, because that is, as you, like, this is a huge amount of utilization here for having nothing on it before. If someone's saying that I have an intermittently slow resync, why do I have all of this traffic here? Just at 4:10 p.m. In this case, it was because I was running tests on the system, and yeah, I had a load generator that I was working with. So this is what I wanted. So why is it starting at 2 a.m. exactly is the point that I was trying to make. You're seeing a lot of traffic happen at a certain time. You can be looking for patterns of behavior because you get this output. You're saying, what is the pattern behavior that I have for the particular things that I'm searching for? So network activity on particular interfaces. I don't think there's a way to break it down by interface, or at least if anyone knows, let me know, because I don't know how to refine SAR any finer than these flags that I have, but this gives me each of the interfaces and how much throughput was going through them at a particular point in time. So, excellent. So, yes, hello.
Yes, is it possible to get the amount of memory that was used over time as well?
Oh, absolutely. That's a great question, because I have a whole, you said memory, right?
Memory, yeah.
Oh, well, yes, great, because I have a whole thing on that. Yes, yes. SAR is super useful. It's incredibly versatile, and you are able to filter down. Also, notice when I set up SAR that I wasn't like, okay, I want to do a network test. I didn't need to do that. I just let it get everything, and then I filtered for what I wanted at a particular day. So I know that we all are sort of inundated by information. Sometimes it's an information wall. You need to figure out ways to break it down, make it smaller for your human brain to pack it in. And this is one way you could see it. You can say the time. Hello. Yeah.
You said SAR, the SysStat packages for Debian-based systems, is there an equivalent for RHEL? Is that available?
There is. It also is SysStat. I do not believe that it is based on cron. I do believe you configure it slightly differently. I didn't have time to get into both scenarios in this case. I also wanted to show cron for that setup because I do believe in, like, Alma, you do it, I think you do it through systemd. But it's slightly different. But it is through SysStat. SysStat package is one you would use. All right, so why do we have activity spike at 2 a.m.? I don't know, maybe it's a backup.shell at 2 a.m. Could be. It's something to look for. I would have, in a normal situation, in an actual day-to-day in my job, I would ask, like, I would probably look in cron myself before I set it and forget it. However, let's say that this wasn't just directly on the system. Maybe it is just traffic that's just hitting that system. This isn't a cluster anyway. So not everything's going to be scheduled directly on it. It's just something to keep in mind. Especially if you look at multiple days over time and you say the same thing happening at the same time every day, something to keep in mind. Just something that you can say, is this a scheduled activity? Why are we seeing this now? And then you can look for processes or other activities that are happening within the data path that might coincide with that. Just one way you could do it. Yeah, in this case, this was just, this is an iPerf 3. Just congest the entire thing, throw it at it for a while, just to make a little demo. So that's SAR for you, but we're going to continue to talk about SAR throughout the rest of this lecture because it is really useful. All right. We're going to go back to Demo 3. It's not going to be all like this, don't worry. Okay. So now we're going to the next scenario. Ah, yes, here we are. this one. Control plus. We good? Oh, well. Cool, wonderful. Because this one, actually, I will want you to see the details on here. So I appreciate you letting me know about this. So this is a scenario that we have sort of building on the other scenarios. You go into the system. I'm not just going to go through top again. Like, you're going to go through system. It looks like the activity's fine right now. I'm not seeing any, like, huge amount of utilization anywhere. Not a particular process that seems like it's hammering on one single processor. And I also looked through SAR earlier, and I didn't see anything historical that seemed of note. So, but why might that be? This is just a particular case that you might want to check for. So, let's not forget about the E section of, the E section of the use method. We want to look at, what do we got over here? So I didn't see any heavy CPU utilization, but like, it's running like hot. So that's an interesting thing to note. Why is it so hot? And don't, like, it would say demessage, not demessage.o. I actually didn't know what would happen if I just replaced demessage, so I just put it I just made a different file. Let's say I wanted to look at just the, okay, well, not, oh, extract. Okay, well, not that one either. I'm going to go in a var log. Yeah. Oh. Okay. Okay. So this is one that it's specific to the application that I work with a lot, and that is a CoroSync. It's got a heartbeat between nodes. The nodes need to know that that the other one is alive, so that it doesn't. So they can do what it needs to do, avoiding split brain, knowing that it needs to kill the other one in case it stops responding, things like that. Really important that these stay connected. So I happen to know that this process is a real-time process. That's basically the highest priority you can have. It'll like everything at the expense of all of this process. It needs to happen. But it's telling me that this has not been happening, like this full seconds at a time. We're not seeing this being scheduled. But again, why are we not seeing some heavy CPU utilization? Why are we not seeing in SAR? We're not seeing all of this traffic happening with CPU. Why is it not being hammered? Well, it's because in this case, this is a VM. This is a VM that is on a hypervisor. What can happen is there's a few things that can happen when you've got a guest and you have noisy neighbors. You have a hog, a different tenant perhaps, that uses all the CPU on the hypervisor, and then this VM didn't get any. He can't schedule anything, but it also can't really tell you anything about that. No, I'm dying. It can't do anything because it doesn't have that visibility. In most cases, it does not have that visibility. This could be also a case where the VM was paused on the hypervisor. It's not going to be able to tell you. I don't think it was in this case because the heat, the temperature, but that's something just to consider that it might be. Let's see, what did I say else about that? Yeah, one thing that you can look at that is an indicator is VMstat has, if you do a VMstat, you can see. Let's see if I had the VMstat in here. Did I have VMstat? Let's see what I got. VMstat. No, I just had, because it's just VMstat. VMstat's one you can use. I wanted to show this. There's a lot of ways to see the ST here. I think I want to use the VStat. We see that on top as well, that ST. Do we see it on top? Yeah, we should see it on top somewhere. But the ST, that's CPU steal time. That's steal time. Steal time is when a VM is waiting for a CPU from the hypervisor, and that's the amount of time it's like waiting for that. So if you see high steal time, that might be an indication. It's not necessarily going to always show that way because of the situation I've described, especially if someone paused a VM to back it up or something else happened. So that's not going to be a guarantee. That is one metric, though, that you definitely want to keep a look at, especially if you know that you're working with a VM. A lot of times in my work, nobody's going to give me the hypervisor logs. They are just saying, well, this cluster is slow. They're not going to say to me, well, because I didn't give it resources to run. That's also another thing, is that people could, on the hypervisor level, that someone could get, could intentionally under-provision something and to keep it and rein it into a certain amount of CPU or any sort of resource usage arbitrarily. So it might be kept at a bottleneck because it's been told to, but it doesn't know that. So just something to keep in mind. These are factors to consider, questions to ask, and defining a problem statement. One question to ask: is this a VM? Could you possibly give me some information on what's happening with this hypervisor during this time? That would be helpful. If they can, I would love that. You would love that. Everyone would love that. Everyone liked that. Okay, so this is not going. Surprise! It's different. Okay, so this is demo number 4, but I wanted to show you something about it before we dove into it. I wanted to recall that functional block diagram that we were talking about earlier, because this is to give you a primer of like how this is working here. Is that DRBD, it does a synchronous write in most cases, where you have a primary that gets the writes. Something's written to it. Now it needs to make that synchronous copy, and it needs to do that over the LAN. So the network here is oftentimes the weakest point. That's often one that I'm going to look at if I'm looking for a bottleneck. It's also one that's fairly easy to check. Something that's easy to check is, something I want to check first, because production systems are fussy, and I'd rather do the easy things first. So that's just giving you some context of why did I check the network first. In this particular scenario, where someone is saying that they're not getting the IOPS that they were promised on a newly deployed system. They said that they did tests before. They thought that they should be getting a particular the network latency that they're saying is higher. It could be a bunch of things in this case. I'm not sure what I wrote about that. But they're not getting the IOPS that they originally benchmarked for. But I want to check the network. I could do it. If I was not on a production system, I could do some A to B testing. I could shut the network, like the functionality for DRBD. I could say, just do the reads. Or just write to the just write to the primary. Don't even do the replication to the secondary, because then it's not waiting for the acknowledgement across the network. It's not going across the network at that point. I could do that, but they're using this system. I'm not going to do that. So what do I do? Well, okay. We're going to go back to boink. Oh. I'm going to use Control+ all the time. All right, what do we got over here? Oh, yeah, all of my stuff. Great, wonderful. Oh, yes. So I want to see how they've configured this. I want to see, in this case, this is a DRBD specific command, but that's just so that I can see what is their traffic running on, how are they configured. So we see some IP addresses here. We usually say for a DRBD setup, if you could put it on a replication network specifically dedicated for replication specifically, so its own little lane of traffic, because then you don't have to deal with other traffic management or other applications that are happening within your network that are potentially going to congest everything and delay replication. We just want something nice and clean and dedicated. One thing that is helpful for that, and this client did do this, is helpful is that I can also, it's better for diagnosing particular issues with if we're seeing some slowness there. Oh, I got close again. Okay. Oh. All right. So what did I say that we could do now? All right, so I do want to see at that point, what do we got? What's this configuration look like? What interface is that? What interfaces do we have on this network here? And we've got these ones here, and we can, through the, we can take a look here, IPS. I'm sure people use the if config. There's some deprecated ones. IP, I think, is like the one that we should be using lately. IP link show should give you some information on the interfaces, and that's specific to the traffic that you're seeing on them. You can see some things that could be indicative of issues with the network, could be a large amount of dropped packets. But what we're looking for right here, in this case, we just wanted to see what interfaces we have and the overall setup of this interface. Let's see. Did I do the link show? Yes, I did. And that was the S link? Yes. And then I do the ETH tool. Ah, yes. Cat, Procnic Dev. That's another way we can look at it. A lot of these are, they're looking at the same systems counters. Here's just a different way to get it. Use what feels good to you, because a lot of times, look in the documentation on what system counter it is referencing. That's another good thing you might want to do when you are doing diagnostics, especially if you are using some manner of observability tool, is to use these different tools and use tools that do the same thing and see if you get the same number from it. And if you get different numbers for running what you ostensibly thought did the same thing, well, now you've got reason to look at it. Is it maybe not quite what you thought? All right, so we've got, that's just another way that we can look at this interface, and we can see the number of packets that are transferred over it, and if there is potentially anything associated. Do I have my ETH tool command? Because I have a ETH tool. Yes, I wanted to look at particularly that interface that was configured for DRBD in this case. So that's ETH tool. ETH tool's great because you can use it to find what is the static configuration, how it is, what is its currently negotiated speed. See its full duplex here. It is, yeah. This I wasn't very creative with this particular demo because I ran out of inspiration. So what I thought in this case was that this person said, I did some NIC trunking and I should be getting double this. They said that, oh, well, but no, I'm just checking behind them, and I said, no, this is a misconfiguration. So the reason they're not getting what they expected is that it's not configured correctly, but this is just one way that you can check what are our assumptions versus what is the system telling us. It's quite easy to misconfigure when you're trying to do some NIC trunking, and I have seen people that are trying to bond the interfaces together, and they believe they have, but they made a mistake somewhere just because it's difficult to do sometimes. So just something to keep in mind. Check behind yourself. ETH tool is great for doing that. Let's see. What else did I say about that? Yeah. SAR. We were talking about SAR earlier and its other uses. I love what SAR does for what you can look for the network statistics. We looked at these earlier, I think, for the, yeah. Now, So what I want to say about this one is that if you wanted to be able to measure throughput, notice I'm doing SAR every second. So how many things are how many packets are transmitted, how many are received per second? Well, you might need that metric, but now you're doing it per second. Now you have it. Just keeping that in mind, like that's a way you could do it. You can average these out and do what you need to if you're not necessarily getting that metric where somebody is doing the math for you. You could do the math also just by running SAR every second. I don't know if I also just showed SAR before. This is just, you can say how often to repeat it. This is, if you put 1 here, it's once every second. You also can enable live mode with SAR without having to enable historical data. Just a cool thing. If you just have it ready to go in the chamber, you don't need to set anything up in advance for it. I use SAR all the time. A couple other things that aren't, well, they don't fit into the demo, but I'm going to do them anyway, just so that I can say some things about them. There are a couple ways that you can check for latency on the network, but let's say that we wanted to do ping. You could do, ping is a valid way that you can measure round trip time of an ICMP echo packet. I just want to say something about ping. A lot of times, firewalls, if it doesn't outright block them, it will put them at a lower priority, these packets that we're sending. So you're not necessarily going to get an accurate measure of what, your TCP traffic. We're going to shut that off. Traceroute, same way for traceroute. But traceroute, so it will also get deprioritized by the firewall sometimes, shows each particular hop, might be useful for you. You can, I'm just, I think I did it 8, I was just doing it to the Google DNS, just 8.8.8.8, might as well, easy to remember. But you can use, I don't know if I did this here, but you can use the T flag on traceroute, and you can switch it to TCP traffic. So you want to get around where it's going to be deprioritized, just switch it to TCP. You could do that with traceroute. Just something to keep in mind. All right, moving right along. Now we're going to get into, well, it's gonna say what you expect it to say. Demo 5. All right. I'm doing on time. I just want to make sure. I think we started a little bit late, but I'm going to make sure that we can, I'm going to kind of speed through these so that we can make sure to be, get y'all to dinner and whatever you need to on time. Let's see. So this person said for DRBD, they extended the disk size. You can do that. Let's say that you've extended the backing volume through a variety of methods. Extend the file system because it's, you're able to do that. LVM, they made the backing volume bigger, and then they resized the DRBD volume. You don't need to know necessarily how that works, but that did work for them. They said that worked. It got resized. I could use the space. But now my system is crashing intermittently. And what do? Why do? So, what do we look at when I have a hunch? So, let me show you. Oh, gotta put this. How are we doing? Yeah. Thank you. Thank you. All right, so SAR with the B flag. That is going to be showing us particular, you should see what we're looking for is a large amount of page outs. This one is not necessarily showing a lot right now because I think I did not do what I was expecting to do with this, but neither here nor there. Okay, so this is one that we want to look at. Also, if you have swap, swap is not necessarily used anymore on a lot of devices. You might be like, well, it's not hidden swap. Well, a lot of things don't have swap anymore. But if you're looking for page outs That's a high number of page outs is something to keep in mind. Look out for when you're trying to diagnose a memory issue. Sidebar on a memory issue. If you do a free command, that's a common one you use for memory, that can overcount your memory because it also says you have the available memory of what is also shared between, like, you have a library, it's shared between different processes. They're all using that, but it's saying that you have more than you do because it's counting those multiple times. Just keep that in mind. It might not be a necessarily accurate measurement. I like to use the pressure stall information. So we can do that by cutting over here. Okay, so we're not seeing anything necessarily here. This is an average of 10 seconds, 60 seconds, and 300 seconds. And it is where you have I/O stalled waiting for memory. So if it doesn't have it and it's waiting for it, this is what it would show. It doesn't show anything right now. It might not show anything for a number of reasons. It could be a really recent spike. I would suggest you use also, they have the totals. So if you had a spike in the past, then you can say, well, it wasn't necessarily reflected in these measures yet. Take a look at that total, see if that's been increased. So you can take a look at it even if it hasn't been now averaged out. Let's see, yes. Okay, so what was the problem? Well, I didn't actually run the problem because it didn't work the way I wanted it to. But in this case, why did I suspect memory? Because they resized the DRBD volume. DRBD requires 1 megabyte of memory per terabyte of storage. They increased the storage. They did not remember. Well, maybe I didn't remember. But they didn't remember. They could get the size. Maybe they were right at capacity for memory. Then they increased. But now they need all that more. And so maybe they had enough. But now they've increased their map that they need to set up for. So, all right. One last one, and it is my favorite one. So it's the last. All right. So a client says that they have newly deployed cluster, and it's not performing the way that they expected it to. There's higher I/O latency than they expected to have. And I said, how did you run the test? Really important, because how you've decided to write your test for disk I/O latency will make a huge difference in how it is represented. So, let's say, oh, there's disk 2 over here. Plus. All right. So there's a few factors that go on with when you have this hypothetical. Let's talk about working set size. That's the biggest thing, and that's what this demo is ultimately going to show, but I'm sort of speeding through it. In this case, you have a working set size that is very small. A working set size is super small, can fit all the way just in a cache entirely. Cache, as we could expect, a memory cache, super fast. This could be a difference of great magnitude. So like this could be, you could get latency of less than 100 microseconds. If it hit the disk, because that how it could not, it was too big to be fully in the cache, had to hit the disk, then that's way different. That's could be up to like 8 milliseconds, more even. But that's the what I'm trying to say is that the working set size is a multimodal distribution where you have everything that's in the cache, and if it can be done in the cache, it's going to be super fast. You have to hit the disk way slower. Just keep that in mind for if someone has a super small working set size for their application, where all the memory it requires can fit in there. If now they've tested with something different, a different workload that cannot do that, it's going to be a much different situation. All right, so I am kind of, I want to make sure that I respect everybody's time, so I'm going to get back to the slide, but I have everything sort of summarized on here, so I can still talk about it. I'm just not going to be fumbling around on the command line. Imagine that. Okay, so don't worry, like I'm talking about the same things. Okay, so random versus sequential is super important. Random, well, let's sequential first. Sequential is where something has been written. Where it starts is where the last write ended. So the offset is exactly at the end of the last offset. As you might expect for hard disk drives that are magnetic rotational, you're going to have a lot of I/O, disk I/O is seek time, where it's moving around. So less of a concern for SSDs. But if you have just a platter-based drive, if you have a sequential, if you're doing a test with a lot of people will test with DD, which is only going to do like a single-threaded sequential write. Well, what if your application is actually, well, it's not writing sequentially to your disk in a perfect order. It's going all over the place, as you do. You can't really test for that with DD. You can with FIO. So FIO is what you want to use for random writes. So the flexible I/O tester. I love FIO because you are able to, not only can you do sequential, but you can also do random. You can toggle various settings, the amount of, you can fork it into different jobs that you repeat in the same iteration. Doing a test multiple times, oftentimes you can feel more confident in the result that you've done multiple times versus just one time. You gotta think also, though, about if you warmed up the cache, that might be a factor. Ideally, you would be able to clear buffers and caches between, like, let's say that you're just writing to it, especially if it's the same type of write. But we're in a production system, so we can't clear our buffers and cache. That'd be rude of us. So we're not going to do that. But keep in mind, a warm cache might give you different results. Overall, though, if you're benchmarking in general, repeating the benchmark numerous times in numerous different settings will give you more confidence in the result. FIO is great because you could say just like num jobs 4, perfect. Set it and forget it. All right, so let's see. One way that you can tell, this is how I believe that you should in general can make sure that, well, I'm just going to put this up there. Yeah, because I have there. Nope. I'm going to go back. All right, I'll just have this all up here because, yeah, the size of the individual writes. How can you tell if it's hitting the cache real fast? You're going to run IOStat with the X flag while everything's running. IOStat is enabled in the kernel by default. It's super low overhead, so you don't need to worry about running it. Just keep it running in a different tab while you do your tests. That way, because IOStat is a tool that it really should be called like disk IOStat because it's only doing disk IO. So if you see activity there, and you expected it, great. If you don't expect it to hit the disk and it is, well, now you know. Conversely, if you're doing a test and you see it never hits the disk, you might want to do a different test if you expect that this stuff is going to hit the disks. All right, so just being real fast to be respectful of folks' time. The ratio of reads to writes. So if you have a metric that combines the two, be suspicious of that because your application has a different ratio of reads to writes in a lot of cases. Figure out what that is and test accordingly. But if you lump them together in a metric, you can't see the different results for reads versus writes, so you can get less of an accurate metric to what's happening. Obviously, SSDs, as we talked about with the seek time, they perform differently than magnetic rotational hard drives. Also, they are not, I don't know if anyone's seen the YouTube video of Brendan Gregg shouting at a disk array. I would say it's super funny if you ever want to check that out. This was back before they like sort of did more soundproofing, and this was, he had JBOD in a server room, and he just, and then he can say, oh, look, the IO latency went way up. It's great. Love it. Because of the vibration, because it didn't like it. Yeah. The disks didn't like it. And the RAID configuration can make a big deal as well for what's happening with how things are written for your application. If you have parity RAID, so a RAID 5, so like that's you've got a parity disk, you will have to do a lot more calculations for parity that are going to cause a lot more I/O operations to happen. It's going to be less performant than, let's say, a stripe, so across a couple disks. Stripe size is another concept of RAID that can be configured, but the size of the writes can be matched to the kind of stripes of how the data is composed across that disk when you have your different disks that you are adding together for your increased performance. Match that stripe size to what your workload actually is. Find out what the size of your writes are, and then you can get a better stripe size. If your writes are bigger than the stripe size on the disk, you might have some problems because it can't. Now it's got to move around a lot for that. We have size of the individual writes. That's not only that. A larger write is going to generally, it's going to have higher throughput, but the latency is going to go down. So just they behave differently. A little write is going to behave differently than a larger piece of data that you are writing. All right, I sort of flew through this one. So I'm trying to see if there is anything else before I go to the last slide, because I know that I'm kind of going over. Yeah, okay. You could use the direct options to try and to account for not hitting the file system when you're doing your disk I/O tests. You can do that for DD as well. Just keep that in mind. It might not be appreciable. Most of the disk, the I/O you're going to find is disk I/O. One way that you can check to make sure that it is actually disks that are the problem, your bottleneck. Check your total application latency for, like, let's say, so we're doing a macro benchmark, talking a macro benchmark again. And if the latency for the whole thing matches what you're seeing in I/O stat, that's probably the disk because you just found it. There it is. It matches. If it doesn't look the same, might not be them. Might not be them. All right. Okay, we're just gonna do. Yeah, we already talked about I/O stat. I/O wait is interesting because it's a little bit deceptive. I/O wait is the measure of the time the CPUs are waiting for disk I/O to complete. But keep in mind that's how busy are your CPUs is a huge factor to that. So let's say that they're performing some super inefficient processing. You're doing bad things to these processors, and they're working hard. Well, then they won't notice that they're waiting for anything because they won't have time to do anything to wait for the disks. It could be that you will upgrade a system or you make a program more efficient. Now you're seeing some higher I/O wait, and you're like, but I upgraded the CPUs. Why am I seeing more of this I/O wait? Because now it has time to wait. But conversely, I/O wait can go down, and that's only because your CPUs got bigger. Your problem might have gotten worse, but you won't be able to tell. So you might need to. That sort of relationship is just something that you want to consider. Any I/O wait, keep an eye on it because that is very indicative. There's a bottleneck in the relationship between those two. It's very vendor-specific, SmartCTL or RAID controller tools. Those are from the vendor, but you can pull them accordingly. And if you need to check individual disks to scrutinize them, then that's how you do. Where do you go over there? Well, CPU profiling, you could do that with perf. We didn't have time to get that today. We didn't have time to get to a lot of things, but we certainly didn't have time to get to perf, and we didn't have time to get to eBBF. I genuinely, it's so exciting if you read about it, though. So I would say these slides will be available for SCaLE. So if you have not looked at the extended Berkeley packet filter and the extensions thereof, definitely take a look. Thanks. Okay, well, overall, what I've said to conclude, what I said is that I've said a lot of things about DRBD and clusters. All of the tools that I've focused on and mentioned, those can be ran in pretty much any Linux system, and hopefully there's some things that I've shown today. They might not show you everything, but they hopefully are directionally correct. And sometimes that's as much as you need. And you're just trying to narrow it down. You don't have a lot of time. And you don't have the overhead to do a stack trace. This might give you just as much correctness that you can put out the fire and you keep on moving. All right, well, I'm going to definitely, if anyone wants to get questions, I have my business cards and stuff like that. We can talk over email. But overall, now I'm going to let y'all go so that you can go get dinner. Yeah. Yeah.
Can you describe briefly CPU wait versus CPU ready time for VMs?
The CPU, like, are you talking about the I/O wait?
No, for the CPU wait and CPU ready. One is for the hypervisor, one is on the hypervisor side, and one is in the VM side.
Well, we talked about steal time. I'm not sure. I don't think I mentioned steal time. I'm not sure. Steal time. Yeah, steal time is the one that's on the VM side.
Okay, how do you spell that?
STEAL.
STEAL.
Yes, like steal, like you stole it. And so
Word, steal time.
steal space time. But it also is, when you look at it on top or VMstat, you're going to see it as ST. But in the man pages, you'll see it as steal time. But that's what it's, steal time.
SEAL.
Steal time.
STEAL.
Yes, like I've taken something from you and you did not want me to do that. And you've said you have steal. Yeah, I didn't do that correctly.
Okay, and where would you see that?
You would see that when you're on the VM level. Yeah, you can see it in top, and you can see it in VMstat as well. There's a couple of other metrics. Steal time is shown in like a collective. Some of these that have a bunch of different performance metrics they show. So SAR is one you could also see steal time as well. Certain flags for different, your tools of choice. You're going to often see steal time, but this is what it's going to refer to universally.
So just when you do top in the VM, it'll be in the table?
Yeah, it's in the top section. It's in the top section of that. Yes.
Top of the top.
There's a lot on the top of the top, so I won't say it's the tip top, but I will say it's in the top of the top. Yes.
Okay, thank you.
Yeah, of course.
Can I quickly ask you?
Yeah.
You said like IO stat doesn't like report like network statistics, but what about NFS, which is a kind of storage place?
Oh man, so the NFS has its. I didn't want to get into NFS storage either because that is a whole different beast.
Okay.
Yeah, because NFS, it is separate, but I would consider that a logical I/O. So that is not physical I/O, and so IO stat would not be reporting on that. You would not see that. So you would only be seeing physical I/O of the disks of the movement. Logical I/O, which that would be covered under.
It's gotta be